vacuum of space is a medium that we could travel to, or that it actually exists. Now, is there any information that you could give me? Remember, no right or wrong answer, just what you know as to how far you can verify that when you look up at your night sky, that it's actually a vacuum that you're staring at when you look up.
Well, we could see that because we're not talking about a vacuum cleaner here. We're talking about
Okay.
Vacuum means emptiness in our case. So there's nothing there.
Okay.
Yes, so it's a physical place we could travel to, yes. Because there's nothing, no air, no oxygen molecules, no nitrogen molecules, nothing like that.
So. None at all.
All right. So everything
maybe one or two, like
all right,
per like 1,000 kilometers, maybe.
Sure.
Around.
So all this information is verified by you. You said, like, you verified it to be true that when you stare up in your night sky, that's indeed a vacuum. Absolutely, 100%.
Yeah, because I have a telescope, like one of those 10-inch wide telescopes, and I've watched the International Space Station fly past the moon. I'm just saying.
So you're
fake.
Right. So you're seeing things from the ground, and you're believing that the sky is a vacuum. Look, what I'm saying is, have you verified that it actually is yourself?
Well, I haven't been to space, so no. I can't.
Okay. So no would be
can't either.
Right. Well, I'm not disputing. This is the thing, Spooky. I'm not debating you. I'm just gathering the information honestly from your point of view as to what you know. So yeah, you conceded. You said I don't know. So right now, the vacuum of space being a reality to you is just a belief. So it could be that you're trusting sources or astronauts or whoever it is, but it's just a belief that you have that the vacuum of space is a reality, and it's a medium that people can travel to. So I'm going to go ahead and round off the 3 points that I propose to you right now, that the curvature of Earth being measured either in ancient times or now is just a belief. Axis rotation, that you trust in sources.
But now you're twisting my words. Now I didn't.
No, I'm not twisting.
Hey, he's talking, man.
Let me finish real quick, Spooky. So this isn't, like I said, this isn't a debate. It's just gathering information from what you told me. So that's all I'm doing, repeating it back to you, and I'm kind of making it to where you can see all 3 points together. So the axial rotation point you told me is also something you learned from a physics class, and you trust those sources, so it's a belief. And the vacuum of space being a medium that we could travel to, or that it actually exists, is still just a belief. So the paradigm of the globe Earth as presented to you throughout your whole life has been a belief that you held strongly to, but it doesn't have any basis on known reality, as in it hasn't been measured, you haven't detected it, and you haven't been there. So there's nothing that you could actually say right now that would justify a belief that you have in your mind.
Well,
so when you would move forward in the conversation, because we're going to open it up so you can ask any questions you'd like about flat Earth. But if when we open up the conversation and you revert back to trying to justify it, we're gonna let it known that what you're trying to do is assert your belief once again, when it's already been known that you just believe it to be true. You follow me, Spooky? So it's not something that you could test and verify because you haven't done it yet. So you're just asserting a belief. So when we get into a conversation, which I'd like you to have with us, don't revert back to like, well, what about pictures from space or something? Because all these things are just rooted in your mind as just beliefs. So,
well, I have a couple.
Yeah. Go ahead. Yeah, no, I'm just going to open up the conversation now, but just to let it be known to everybody here that you did concede and said it was just a belief. But so if you cannot, try not to go back and try to justify these things as if they're actual known reality, because just right now you conceded to yourself that it's just a belief that you carry. That would be it. So I'm going to go ahead and open it up, and you can ask any questions to people here who would take any questions for Flat Earth. And if you want to know,
you mentioned Bob, why don't you start with Bob?
Yeah.
Sorry.
I have one question only.
I didn't
fast question. I only have one question fast about Bob.
I think he's right. We should let Bob cover that attack on him if he wants to.
I'd be more than happy to cover it.
Without interruption, please.
That's exactly what I was going to suggest. This is going to be awesome.
Okay, so obviously you don't know me, right? You only know me because of what you saw in Behind the Curve, correct?
Yeah.
Okay, and from what I said in Behind the Curve, you took that and interpreted as, what I was saying is that the Earth was spinning, right?
Yeah, you said 15 per 1 hour and 15-degree drift.
That is correct. That's exactly what I said. And you know what? I wasn't lying. That's exactly what we registered. The problem is what the producer interpreted that and actually cut the editing to make it look like. So would it surprise you if I told you that, I completely agree with everything you just said. I absolutely did say that, but unfortunately, because of the way the producer twisted that around, I was not saying 15 degrees per hour of Earth rotation. Now, do you want to know how I know that?
Because your gyroscope, your like $40,000. What was like? How much was it?
Well, first of all, it wasn't my gyroscope, and second of all, I didn't do the initial test, but I got credited with that, so I'm just gonna wear it, okay? But we took that gyroscope, and like I said, when we first plugged it in, we got a 15 degree per hour rotation, and actually, it wasn't specifically 15 degrees per hour. It would be an interpolated value, taking the sine of the latitude times 15 degrees per hour, which would kind of equate out to that. Okay, so let's make that perfectly clear for one thing. But secondly, when I was in the movie, yeah, at that time when I stated that, I had no idea. I was just as surprised as anybody else, and yeah, I was very reluctant to accept it because I was trying to interpret, exactly what we were seeing. And I came to find out later on, and by the way, I did tell the movie producer this, exactly what we were seeing had actually been measured and discovered over 100 years before in what was called the Michelson-Gale experiment, right? The rotation of the luminiferous ether. So at that point, then what we were faced with is we had the challenge of, well, how do we prove that it is not Earth rotation and was in fact the luminiferous ether? Now, some people, and I'll even say even in this panel, don't believe necessarily that the luminiferous ether exists, but there's also a lot of Nobel laureate, physicists that say that it does, and it's, there's a big debate on it. Let's just put it that way. But by using that very same gyroscope, whether you believe in the ether or not, we actually devised a way to tell us whether or not it was in fact Earth rotating, okay? And it was really pretty simple, right? So first of all, do you understand at all how the fiber optic gyro works, how laser interferometry works?
Well, not really, but I mean, I get the gist of it. I get how a gyroscope works and how the gravitational pull works on it. And then when there are spins, there's different. It marks one spot, and then it calculates the time interval it takes. Then it calculates the angle, how much is the angle is like changed.
Well, that would be for a gyroscope, yes, but a fiber optic gyro works a little bit differently. It works on something that's called the Sagnac effect. And the Sagnac effect is basically, it goes under the assumption that if light is traveling through a medium, right? In other words, they speak of light as a wave, right? So you have to ask yourself, well, what is a wave? What is it waving, right? What is it traveling through to cause that wave? What is the medium that light is actually waving, right? Well, scientists have been saying for centuries that it is in fact this luminiferous ether. And that is what I actually wound up claiming that it was that was actually rotating, the luminiferous ether. Now, here's how and why I came to that conclusion. So we went back and we looked at these experiments from over 100 years ago and the assertions about the Sagnac effect and laser interferometry. And it turns out that what they say about the luminiferous ether is that it rotates very much, or it behaves very much like a magnetic toroidal field. Are you familiar with a toroidal field in a magnet?
Yes.
Okay, so the ether very much behaves in the same way. It actually is moving. It's not a stationary thing. It is moving, and believe it or not, it propagates vortexually, right? And it just so happens that that vortex rate is about 15 degrees per hour. Now, again, how is it that we were able to figure that out and that it was not Earth rotation? And the answer is really quite simple. So if I'm taking, and this is, by the way, exactly what we did. So we took the fiber optic gyro and we went to a place in Colorado called Pikes Peak. And Pikes Peak is at 14,125 feet above sea level, okay? And we did our measurements there, and we got our essentially our equivalent to the 15-hour rotation rate from Pikes Peak. Now, again, whatever you want to call it, you know, you can call it the ether or you can call it Earth rotation, you know, whatever you want to call it, that's fine. But what we're trying to prove here is that it was not Earth rotation that we were picking up. So we did that measurement at Pikes Peak, and we got a value for it, okay? And then we went down to eastern Colorado following the exact same line of latitude, right? And why we followed the exact same line of latitude, I'm going to tell you here in just a second. But we went directly east in Colorado on the exact same line of latitude down to just over 4,000 feet. And then we did another measurement, okay? So would you agree that if I am measuring something that rotates or that measures spin, right, or a rotational rate, that it should not matter whether I take that rotation rate at the bottom of a device or at the top of a device, especially a spinning ball. It would be the same whether you took it right on the globe or an inch above the globe. Would you agree with that?
Yes.
Okay, and you would be absolutely correct. It would not vary at all because it doesn't matter where you would be, high or low, on that same latitude line. It is going to rotate at precisely the same speed. Well, here's the problem with that. What we found was that when we did the measurement with the fiber optic gyro at the 4,000 foot elevation, we had about a 1.3, 1.4 degree per hour variance from that done at the 14,125 foot elevation on Pikes Peak, okay? So we thought, well, that's pretty interesting because that actually equates to be 26, 27 degrees per day, right? That's a huge number. So we did it again at a different place, Guanella Pass, and again, and again, and again. And we did it in several different places in Colorado. And again, each time we then went to its corresponding latitude line at a lower altitude. And every single time we got a greater than 1 degree variance on the two measurements. Well, why would that be? Well, if you think back to what I just said about how the luminiferous ether was always said to propagate, and this comes from the people that coined the term, you know, Newton, you know, Maxwell, Clerk Maxwell, all these people that talked about this originally, then all you have to do basically is visualize it as a vortex, i.e. like a tornado, okay? So if you are looking at a tornado and you look at it on a z-axis, right, then at the top of the tornado, right, it's rotating fairly slowly, and as you go down that z-axis down towards the ground, it rotates faster and faster and faster, right? So you have a considerably faster rotation rate at the ground that you do, you know, from high up in the air. Would you agree with that?
Yeah.
Did I lose it? Okay,
yeah,
good.
No.
All right. So that, again, is exactly what we are saying that the luminiferous behavior is propagating as, right? A vortex. So the problem here for the globe is that when you get a 1.3, 1.4 degree per hour, which equates to 27, 28 degrees per day, something like that, difference in rotation, then that pretty much tells you unequivocally that what we are picking up is not Earth rotation. And it is more commensurate with that vortexual behavior that science has always told us that the luminiferous ether actually behaves in this vortex, right? So we did this multiple times, and every single time, you know, we weren't expecting such a huge variance. But, you know, when you're talking 1.3, 1.4 degrees per hour, that's actually huge for 10,000 feet. So we can only imagine that that number grows even greater if we were able to go higher and lower. But the most important thing is what it proved unequivocally is that what we were picking up was not Earth rotation. And do you see the logic behind that as to why we know that it wasn't Earth rotation?
Yeah.
Okay, so that's it. So whether or not anybody wants to accept that it was in fact the luminiferous ether, as I claim, and as as other people claim, that's up to you. But the primary goal here is to prove that what it did pick up was not Earth rotation. And in fact, when they did this over 100 years ago in the Michelson-Gale experiment, they had to do another experiment called Airy's failure to try and determine what exactly it was that was spinning. Was it the Earth or was it the sky? And so what they did was they devised a very simple optical experiment called Airy's failure, in which they measured the rotation rate optically with the telescope, and then they filled it, full of water, and theoretically that would slow down the propagation of light through the telescope. And then the idea was that if they had to tilt the telescope further forward, then the light would not be coming in at the correct angle. However, if they didn't have to tilt the telescope forward, then the light was already coming in at the correct angle of 15 degrees per hour, indicating that it is in fact the stars that are rotating and not the Earth. Well, guess what? Airy's failure, same conclusion. It concluded that it was in fact the stars. So now not only do we have the FE cores version of testing whether or not it was Earth rotation, but we also have Airy's failure from back in antiquity. And to this day, you still have people saying, well, we built these gigantic laser interferometers that are stationary and sitting in one place, and of course they are going to be picking up a rotation just like we did. But the problem is there's no way to falsify that if you cannot move that detector up and down on a z-axis to see if whatever it is that you're measuring is changing velocities at different altitudes or different z-axis. Okay, so that is how we know unequivocally that what we were not measuring was Earth rotation. And of course, because the producers of Behind the Curve did not want that information to come out, they skewed it and made it look like, wow, dummy flat earthers, they proved it, with their own equipment, and then sit there and keep denying it. Well, they didn't include the rest of the story, and that's kind of the problem that we have with Behind the Curve. And that's all I have on that, unless you have any questions.
No, I'm just wondering why. I mean, it's just weird why they wouldn't include it.
I'm sorry, it's weird why they wouldn't what?
Include it, because like lots of people, I don't think you've told this to many people.
I have told this countless times. It doesn't get any press, and I told it to them, and I'll tell you why. And the producer even said it himself. They were all for giving Behind the Curve a fair representation until they went to the 2017 Flat Earth International Conference in Raleigh, North Carolina. Okay, then at some point I don't know, either primary or junior high school kid got up, expressed his beliefs in flat Earth, and he said, Clark, whatever his name was, Mr. Clark, that did the documentary production, said that he and Caroline decided at that point in time that this was too serious and they had to stop it. And they decided at that point in time that they then had to change around the theme of the movie to make it more of an anti-flat Earth propagation piece. Now, they said this in their own words. Daniel Clark, by the way, is his name. He said it in his own words, and he said the same thing to us. It's like, okay, now this isn't funny anymore. You've got kids taking this in, thinking that it's serious, and so now we're going to turn this around on you, and that's why they didn't include it. That's exactly what they told me, and that's what they are actually in public saying. Okay, so in other words, this flat Earth idea, this paradigm is so powerful that it will change lives. It will change everything about this world, really, that you ever thought you knew about it, and it exposes a lot of things, to a lot of people that they simply are not ready to handle yet. And so that is why they decided not to do that, and that's exactly what they told us.
All right, Spooky Elon, did you have any questions for Flat Earth that we might want to engage any discussion on, or?
That was awesome.
Yeah, I really enjoyed that. Thank you for that.
You're very welcome.
Yeah, guys, thanks for letting him talk uninterrupted.
We get that all the time. You see how crazy that is, bro? Like you said, your instinctual response was, why would they do that? He explained their little story for it, but isn't it interesting that you came in here having a complete misrepresentation of what the actual stance was? If what they told you about it was true, which is that it's archaic, unfounded, and just preposterous, stupid, then they would never have to do that, right? And you've now got the context of just one of the misrepresentations, which was a Netflix film. Firsthand, you couldn't have got a better explanation, but this will be a reoccurring theme. This is because there is no debate against flat Earth. Flat Earth is objective.
Yeah, the one thing I wanted to ask Spooky Elon is if what Bob said is 100% true, and I completely obviously believe him, why did they have the opposite reaction that they should have had? So if this is true and it's serious, why would that force them to make it anti-flat Earth? Surely, as a well-meaning producer, when you discover that something actually isn't a joke, you should want to push it out more.
Well, I think a lot of that goes back to, people's cognitive dissonance. I mean, let's face it, flat Earth is an explosive subject. It completely screws with people's realities, and they simply, I hate to coin the term, but, it kind of goes back to that movie where Jack Nicholson says, you can't handle the truth. Well, a lot of people can't handle the truth. I mean, because this, what flat Earth actually represents is a change in paradigm that is so severe that it literally wrecks everything we've ever been taught for our entire life, And as flat earthers, it's much easier for us to understand things like, that these frauds are going on, like Sandy Hook being a fraud, like Boston bombing being a fraud, like 9/11 being a fraud. We see it over and over and over again, but this is a big one. When they're talking about, wow, we're not in outer space, we're not on a spinning ball, that there had to be somebody that actually created this place for us, which is a very logical and sound conclusion. It's just something that a lot of people can't handle. And by the way, there's a lot more evidence, to kind of support, well, not support, there's a lot of evidence, period. In fact, all the evidence pretty much supports the flat Earth position. I always talk about what I call the preponderance of evidence. And, when you look at the preponderance of evidence being that, we cannot measure curvature anywhere, we cannot measure spin rate anywhere, we cannot measure these very slight changes in inertia between perigee and apogee. People will say, well, of course you can't feel that with your senses. And maybe you can and maybe you can't. But one thing that they neglect to say at that point is that we have instrumentation that is absolutely capable of measuring those very, very subtle changes, right? They're called accelerometers. You have one in your phone, and they are so sensitive. Well, look into them. They are incredibly sensitive. And so we have all the instrumentation. It's not just the fiber optic gyros that are giving us this information. We have several pieces of test equipment that are, giving us this information. So, and going on behind that, then when you look at NASA and all of the frauds that they do, all the CGI, the fake pictures of the globe, the fact that we didn't even get a picture of the globe until like Apollo 17, right? You'd have to ask yourself, why in the world would that be, right? Why would NASA, admit to making CGI composites and not even giving us pictures of the globe when, what, if you and I went out to outer space, the first thing we would do is snap about 1 billion pictures of every leg of the journey, I mean, everything that NASA is doing is completely non sequitur. It doesn't add up. And when you start looking at it through the paradigm of, well, maybe because we can't go into space, and that the Bible just may be accurate in that there is a firmament up there. And I am a person that believes, that there is a firmament up there. And I say that not because of any religious belief, because I'm not a religious person necessarily, but because of the evidence. When you look at things like sprites and elves and discharges, and everything seems to cap off at this 100-kilometer or 62-mile limit, and all kinds of strange things seem to happen around there, you really have to begin wondering. And then, of course, there's also the NASA and the Army documentation that talks about the firmament that, of course, the ball earthers will want to, completely set aside and dismiss. Great, so set that aside, dismiss that, whatever you want to do. But there is still a mountain of this preponderance of evidence to follow to prove our position in flat Earth. And we can take apart the globe argument at every turn. So this is why. Yeah, exactly. Yeah, gas pressure without a container. Well, obviously there is a container. It's called a firmament, and the evidence for that container is quite abundant, frankly. And I've done several shows on this. So there you have it. And that's just my take. I'm going to let some other people talk about this, but that's just my take on why I've gotten into this.
Bob, can I ask one question?
Sure, go ahead.
Do you know that somebody in human history made some similar or the same measurement you do on that movie, and if you understand, my English is not good.
Hey, Pegasus, how you doing? Did you meet the sex robot yet?
Hello.
Hello. Good morning or afternoon or
Morning.
evening.
Buenos dias, señor.
Yeah. You can hear me?
Yes, we can. It's been a long time. How are
Perfect.
you? Loud and clear,
yeah,
brother.
it's fine.
Yeah, nice to hear you. How's it been since we've seen you?
Yeah. Lockdown and everything hasn't been too nice. But it's starting to become easier. I wish I had more time to research. I feel like I can't really add anything to the debate right now because I haven't had the time to actually do my experiments and such.
Okay. Well, it doesn't really take much experimenting. Yeah. All you got to do is go out and measure. Nope.
Yeah. Yeah, we'll see what I find.
Measure across the lake somewhere? Yeah, it's easier said than done, right? I know.
But Pegasus, have you taken the time to listen back to the recording?
Yeah, I've listened to it a couple of times. It's very fun. I like it.
So where have you been? Hiding out? I was talking to Pegasus.
Hello?
Just curious, like where he's been. You haven't been around. Where you been, buddy?
Yeah, it's sorry, my internet is kind of bad. So if it has disappeared, then you know why. But yeah, nothing really. I've been studying for school a lot.
Oh, I see.
This is the last semester, so I haven't had that much time, to be honest. So yeah, that's my life in a nutshell. But yeah, I was wondering a thing. If you might enlighten me, because I'm preparing to do the Cavendish experiment, and I remember someone disputed that and had a problem with it, and I don't remember what. And if you would be so kind and enlighten me.
There is no hypothesis for Cavendish experiment. That is not experiment.
Yeah. You just look at the scientific method and ask yourself, what is the naturally observed phenomenon? What is the independent variables? And what are the control variables? And then you'll know that that's not an experiment.
Oh, well, just because you don't have a hypothesis, you don't have to have a clear hypothesis to be able to create a theory or a to get some kind of result out of the thing Cavendish was doing.
You have that. You need to have the variables. You need the controls to control the variables.
Yep, but with the hypothesis, the problem isn't necessarily the hypothesis itself, but what it links to. Like, for example, let's say you walk outside, right? Unless you see a weird thing or like a certain phenomenon that catches your eye, you're not suddenly gonna wake up one morning and be like, yeah, these are the results. It's a step-by-step process. You can't just skip a whole step. First, you need to observe a phenomenon, try to understand what it does, and yeah, like separate a dependent and independent and controlled variable, and then you can move on. You can't just skip a whole step. That's not logically sound at all.
Yeah, let me help you out a little bit. A scientific experiment is a hypothesis test. So if you don't have a hypothesis, you don't have any science.
Yes, so what is the effect that you're trying to prove the cause of with the Cavendish experiment? What effect are you seeing that you're trying to prove the cause of?
If I have understood the Cavendish correctly, you're not really trying to prove a cause. You're just trying to prove that the phenomena exists. Because the thing is, you've seen that, well, the Earth and an apple, like if an apple falls to the ground, the Earth and the apple attract, or at least the apple attracts to the.
Why apple falls on the ground?
Yeah, exactly. For some reason, the apple falls to the ground. But
why?
go toward. Yeah, we don't know.
We
but
know.
Then, like,
we know.
Correlation is not proof of causation. The electrostatic force is 37 times stronger than claimed gravity, and you have not isolated for electrostatics with your so-called non-experiment.
Apple will fall because it's going through the air. Is that true?
That might be one explanation. I don't know.
That's because if it's water there, apple will not fall. It will float.
Yeah, but if you would go down, that's what we do now with the apple. But then if you would see, it might be because of buoyancy. That might be why the apple falls to the ground. That might be one explanation. Another explanation is that masses attract each other in some weird way. We don't know how. But that could be an explanation.
Listen, this. Do you see apples falling down in real life?
Yeah.
Really?
Yes.
How?
If I
How
go
long?
out on the
When you look apple in the tree, let's say, how long need apple to fall?
Depends on the height.
Depends on the height, you are saying. Apple is growing on the tree, you know.
Yeah.
And now, how time need apple to fall down?
It is. That's just like classic mechanics. That's if you have the height from the ground, that is equal to the acceleration times squared divided by 2.
I'm telling you only that apple it's stationary. It's not falling down.
Yeah,
it's
Pagis,
growing.
he's not talking about the drop. He's talking about
Okay.
how long will it take for the apple to fall off the tree? Why is it falling off the tree? When it's
That's because
attached to the tree.
That's biology. That's because the apple grows old and the tree drops it because it wants to spread its seeds.
Ah, so you got the cause then.
That means the tree is doing that.
Yeah.
That means the tree dropped the apple, and apple it's now falling through the air.
Yeah.
That's the explanation. Because
Just
apple
like
is
when
more
I pick
dense
up a rock.
and it's falling.
Yeah, when I pick up a rock, I am the cause of the rock moving up, and when I drop it, I am the cause of the rock dropping.
What they need to start calling gravity is the stillness in between time and space. The mass between time and space that is still. That's what they need to call gravity.
No.
Hey guys, sorry, 2 seconds. 2 seconds. I've only got a couple of minutes. I just wanted to welcome Pagis back to the server. Pagis, good to see you. It's been a while. Everyone, be nice to Pagis.
Yeah.
Hello.
Pagis, there's a ladies' night tonight in 5 hours or something. So if you could join around then as well, the ladies would love to speak to you.
Yeah.
Just
I
letting
might
you
see
know.
if I'm up then. Yeah, thank you.
Cool.
Very
Welcome back,
kind.
bro.
Thanks. I'm glad to be here.
That depends if he's a ladies guy, if you know what I mean.
Yeah, no, he's legit. Pagis is good
popular.
people. Anyway, I don't want to interrupt, but yeah, keep it chill.
Yeah.
Ladies, man.
Well,
Can I tell you simple? That apple, let's say that's on the ground, that apple, and now you're moving that apple. When you take that apple, you will move that apple through the medium, through the air.
Okay.
Because you're and that's the less dense things, You will move the apple from equilibrium because apple will not go through the ground because the ground it's more dense than apple,
Yeah.
And then you are taking the apple and moving through that air, what is less dense. And of course, if you now drop the apple will fall down because you move it. The medium it's in. Yeah, that now apple it's in the air, because you picking up the apple and you are dropping now apple. You don't have any phenomena here.
So, if I understand you correctly, the reason why the apple goes back to the ground is because it seeks equilibrium again. It wants to go back to the ground, to the equilibrium point.
Yes.
Okay, yeah. That could be one explanation. I don't deny it. That could be why stuff works. But it could just as much be because there is a force between masses.
No. Well, listen this. You can explain this with the how to say bucket, empty bucket. Drop the ball, the empty bucket, and it will fall down. Of course, Now fill the bucket with water and drop the apple, and it will float.
Yeah.
Now take out the water, and apple will fall down again.
Yeah.
What I am doing in this case?
You're changing the equilibrium point.
I'm changing the mediums of.
Yes. And indirectly the equilibrium point.
Is that reasonable to understand why fall?
Yeah.
That's
I agree. That works.
Pegis, do you understand how he manipulated the independent oh, I forget which one is which. He manipulated one of the variables, just like in a scientific experiment, to show what caused the effect.
Yeah, but here's the thing, which I was trying
That's something the
to
Cavendish
point
does
on.
not do. The Cavendish does not manipulate the variable it claims is the cause of the effect. So it is not scientific. Meanwhile, he showed you something experimental scientific, and you wanna wave it away.
But this was something I was trying to get to in the robot argument way back when. That just because we have manipulated a variable in some way and shown that we do this in this scenario, we got an effect. We can postulate and have a theory that is the reason why stuff is happening, but we cannot guarantee that is the truth. We cannot know.
We can show every time through experimentation, repeatable, measurable, every time, show that the results are the same. You would need to show that there are exceptions to that.
Yeah. What I'm trying to say is that, you can increase the certainty that our explanation is the true explanation.
It's not
but
explanation, man. It's a demonstration. If I show you water boiling with the heat, I cannot speak after that water can boil also with if I put ice inside.
But one thing you could do with that,
because theoretically, if I put ice, also water could boil. Theoretically.
Yeah, theoretically, but that's kind of but one thing is, like, if you do something once, then maybe there is a correlation. If you do it twice, there's a greater chance of a correlation. If you, as you say, repeatable experiment, if you do it a bunch of times,
like with bucket, with water, it's you can repeat it every time, and every time it's happening. That why we need explanation for that is something else happening when we have proved that this is happening.
Yeah, so like we can, but to be guaranteed that the reason,
because of that, I told you about water, how water boils. Why we need to speak now about maybe water boiling? That's good. Yeah, we can show that with heat, waters boil, but maybe that's not 100% true.
Yeah. So maybe the medium thing, maybe gravity.
Yeah, but maybe in fusion.
You're not understanding, Pegas, that scientific method does not deal with correlations. We proved that heat under nominal conditions boils water. When we change those conditions, like we change the pressure, we notice that we can also boil water. So that is just an adding to our information that did not change in any way the fact that we established via the scientific method before.
Okay, yeah, that's try. I feel like I'm not explaining myself properly. Because then we can say in this, if we do let's say we put the water on my stove, and I put heat on, and I see that it boils. We can now say when I put heat on my stove, the water boils, and we can basically guarantee that. But we cannot say a certainty that that is the only reason water boils. And we can't really say how it happens either. We can only see that I do this, this is the consequence, the result.
Cause and effect.
Yeah, exactly. We cannot really talk about then we can postulate theories and different things why it happened. But we cannot, through the experiment, definitely say that one of these theories is correct. We can only talk about cause and effect.
Yeah, but the theories themselves, if they're going to be scientific, they must be based in experimentation. They cannot be based in non-experimentation or pseudoscientific gadgetry that has nothing to do with science, and then claim it's all science. It's just pseudoscience.
Yeah, but isn't Cavendish more about saying a fact, stating that a certain effect exists, and then nothing more?
No,
because the really thing that it does.
The effect of the Cavendish is only within the contraption. It is not existing outside the contraption. There is no attraction between gas molecules. There's no attraction between fat people. There's no orbits around them. It doesn't happen.
How do we know that it doesn't?
Because we observe that every day, all day, at all times. It's only within the contraption that they conjure up something that, by the way, if you're going to be doing it soon, so take note of that when you do it, it is as likely to move apart as it is to go together. So take note of that.
Okay, yeah, maybe I'll see that result. It will be interesting when I do it, because I haven't done it yet, so it's hard to speak about it. But
besides, it's a torsion balance twist. It's not actually. It's just the twisting of the torsion balance. It's not showing you anything that could be even related to attraction, because you're not controlling any attraction. You're not manipulating the attraction between these balls, showing that they attract when you put it on and don't attract when you take it off. You're not manipulating the variables. It's not an experiment.
Well, you are manipulating.
It's just someone creating a magic trick, and then telling you this is what it is when they don't have any control variables to control for effects that are far greater and stronger than the effect they claim is happening.
Well, there is one control variable. There is one variable which you change. It is the distance between the balls.
Yeah, you're not changing any variables and controlling any of the variables there. The electrostatic force in charge of the objects can make them attract and is 37 times stronger than gravity. It can also make them repel each other. So you have no way of isolating and controlling this known effect. So to try to equate gravity to it is preposterous.
No, I'm not saying that we're trying to put gravity onto it. I'm saying that we're trying to see that if there is a force between two masses, and if there is a force, does that depend on the distance between them?
You cannot just claim that there is a force when you have no evidence of there being one.
But isn't that the whole point of Cavendish, to show that there is a force by showing a motion?
Cavendish's point was to try to calculate the density of the Earth, and from that the weight of it. It's nonsense. It's pseudoscientific. It's not an experiment.
Yeah, but regardless of what Cavendish is doing with it,
I cut this from the someone else did, but I saved it. This is from his paper, from Henry Cavendish.
Yeah, okay.
essentially, people talk about this and use this to try to confirm their bias because they believe in Newton and the gravity that was taught to them as children. But later on, when they go on in school, they learn that that's wrong and they need to replace it with Einstein. So this whole kerfuffle doesn't make any sense, isn't scientific, and isn't logical. So when you are going to do this in school, like you claim you're going to do,
no, I'm not doing it in school.
Be very aware of it. Are you you're not doing it in the school?
No, I'm doing it by myself.
Okay, that's interesting.
I have one question. Is that Cavendish very important? Very, very important or not?
Depends. I'm trying to do the experiment.
No, I'm asking, is that important for educational things that we understand the globe?
Doesn't have to be.
Is that one of the best, let's say, proofs what we can understand the globe?
I don't know. The only thing I will get out of it.
I think so because people are repeating that years and years and years now. But I have one interesting question. I never learned about that. You know, you need to search for that. You need to be in special, I don't know, school maybe to learn about Cavendish or blah blah blah. But we don't have that in basic education, you know, about sphere, because that will be so great, because we have one man who proved the globe, and he is Cavendish. You know, that should to be in the first class in the school, in my opinion.
Okay.
But it is not.
So
why we something what is proving and explaining so good the sphere we don't have in basic education? That's my question.
I don't know. I can't tell you that.
I don't know also. That's strange.
Perhaps.
Why? Perhaps we will have something what is good, keep it in secret, and it's good for educational system for kids, for example. Cavendish, like we learned about Einstein, like we learned about Newton, like we learn about Pasteur, or Maria Curie, or whatever.
Bagus, so how are you going to set up this Cavendish experiment that you're talking about? What is your setup going to be? Where's it at? What are all your controls that you're going to have in place?
I'm still like developing. I'm quite far from doing it. I know that I can borrow a space in one of the universities, where you can lock all the doors and the airflow and such and such. So that's good. So then there will be less airflow. I will try to check like magnetic fields. There's any like of that going on, and also like magnetic polar, like the magnetic strength of object, to see if that's something that could be influencing. Yeah. I don't know.
So let me ask you a question. In the setup of the Cavendish experiment, I posted something in the live stream voice text right at the hour. Do you see that with the torsion bar and the 4 different masses?
Yeah.
So let me ask you a question. If there's any movement at all whatsoever with the apparatus or wind flow or anything like that, would you expect the smaller mass to move anywhere but towards the larger mass?
Well, with wind flow, it could move either way.
Yeah, it can move either way, right? So if you look at the setup, there's 4 different balls. This is how it's set up. You have two larger masses that are stationary, and then you have 2 smaller masses that are on a torsion bar.
Yeah.
So those larger masses are in the circumference of the swing of the two smaller masses, right?
Yeah.
So what movement within that apparatus would not be towards one of those masses, one of the larger masses?
Well, it can go two ways,
My point
right?
being, any type of movement, the ground shakes a little bit, the apparatus shakes a little bit, you have any type of wind movement at all whatsoever, you're going to get the result you're looking for, because the only place for those two smaller masses to go is towards the larger masses, regardless of what direction they move in.
True, but it could go the long way around or the short way around, right? It could either, let's say it's 10 centimeters towards one of the balls, and then it has like 2 meters of swing to the next. And if I see that it moves like the long 2 meters, do a full swing, then I know that it's fake. And it's some other, then the wind shaking or anything, then it's not a force between the objects. Because
But if it moves the other way, then that's definitive proof that it's some sort of mass attracting mass?
No, it's not a definitive proof.
Then what are we trying to prove with this apparatus? Because that apparatus is always going to have a smaller mass going towards a larger mass, regardless.
No, if it goes the short way, and if we can see that the speed of the smaller mass increases, and if we can see a correlation, a effect between the distance of the masses and the acceleration, and if we can repeat this, and if we can see that the same cause and effect holds true, we can then with quite high certainty say that there's some kind of attraction going on. It might be the electrostatic force, I don't know. Something is attracting them to each other. If that happens, if it follows the same curve, if the distance correlates to a certain acceleration, then I know. And if I can repeat it like 50 times or something, then I know.
So if you have a very weak wind current that you can't necessarily pick up, right? You're trying to control for it, and you have a very weak wind current that over time will eventually move those balls. If that is not completely eliminated, you will get a consistent result every single time.
Yeah, but then when I try to do the same experiment again, but with another starting position, another distance, and I see that the speed is the same, the acceleration is the same, then I know something funky is going on. Because it should change.
Not if you have the same wind current that you had before.
Yeah, exactly. But if the speed is the same, then I know it's the wind current, and that's the reason.
Pegasus, have you heard of convection currents due to heat?
Probably, but not in the English language. I don't know. If it might be the thing I'm thinking about, then yes. But if it's not the thing,
essentially because the sun heats the building on one side, or there's a pipe that runs with heat in the ground or in one wall, it heats the air around that area, which causes movement of the air in the room.
Huh? Yeah. Well, then, what I'm trying to say, then I will see a movement, and it might be towards the short way. Then I will note down.
How are you going to isolate for that?
I can't isolate for everything. Hopefully, I will be able to, but I can't be certain. But then this is the way I will be thinking. So I look at the distance, and then I can see the speed, the time it took for the ball to go towards the bigger mass. And then I do the same with another distance. And I can plot this on a graph and see the correlation, the cause and effect between the distance and the speed. And then, if I repeat this...
Causation is correlation, it's not causation. They teach you this in 11th grade physics class.
No, I'm not talking about causation.
Well, you just said it.
But then I said wrong, sorry. It's not my main language.
Okay, well, I mean, It's something that at least in English-speaking universities they teach you that correlation is not causation.
No, obviously. I know that. I'm sorry if I said wrong.
Yeah.
I don't think you could ever tell an outside force by using this type of mechanical apparatus. I don't think it's possible.
How do we account for the failures? Nothing.
We're losing you, Indio.
No, we use something like what?
You're fading.
Yeah, it's really windy where I'm at. Sorry.
Okay, no problem. Try again.
I said, how do we account for null results? And how do we account for anomalous measurements, such as if you use something that is so light, nothing should happen, right? So like Christmas bulbs. Say, Christmas bulbs that you hang on a tree, they're so light, nothing should happen, but there's a demonstration in the so-called Cavendish experiment where this happened. And I'll actually post a link to a video where this is tested and observed.
Yeah.
I don't know.
I don't know how you would ever control different contraction rates of materials due to convection currents, like the temperature changes. How would you monitor that, let alone separate it? And then also listen, Pagus, how would you separate the electromagnetic and the electrostatic forces that are inherent in all materials?
That is not what I'm trying to do. That is not the goal.
Oh.
The goal is to see if there is some kind of consistent attraction between masses. I don't want to discuss the reason why, but I want to see if it exists.
So it's not an experiment. So it's not an experiment because if you're not testing for cause and effect, then it's not an experiment. So you cannot have a valid hypothesis. So you're just playing with a mechanical device. That's fine. You can't claim that it's predicting or showing a result that's caused by some external force through this mechanical apparatus. It's not possible.
As I've said 100 times now, I'm not trying to prove the cause. I'm just trying to see if there is a effect, and if I do X, does Y happen? And if I can repeat that, then that's some kind of result. Right?
Yeah, that's cause and effect. If you do X, then Y happens. X is the cause of Y here.
Yeah. That's what I'm trying to see.
You're contradicting yourself.
Oh, yeah, sorry. But when you said cause, I thought you meant like the reason why. I don't want to explain it. I want to just state the fact if stuff happen. You get me?
Yeah, I get what you want to try to confirm. It's your bias. But the problem is...
I also want to see if it doesn't work.
The problem is you can't actually confirm your bias through this because you're not actually proving that mass is causing anything. You're not showing mass doing anything. You're just assuming that mass is causing something and will therefore do that on a larger scale. You can't even define mass, so it doesn't work.
Are we talking about Cavendish?
Yes.
Yeah. So what was he varying, man? I'm just wondering.
Well, hold on a second. We'll get to that.
All right.
So the point is, you're arbitrarily assigning the variable you want as the mechanism that's making the observation happen, right? So
no.
Yeah, you're just arbitrarily picking. Oh, mass is the property of matter causing this to happen, where it could be any property of matter that could cause it to happen, because that's the only consistent thing you're using. You're using a chunk of matter.
Yeah, I'm completely in agreement with you.
Yeah, but so why is the property called mass the causal mechanism?
I don't know. I don't know why people have done that. That's not what I'm trying to do when I will be doing the experiment. That's not what I'm saying. Cavendish might have said that.
I think it would be more interesting. I think this would be more interesting. for you to set up the apparatus, do the experiment, record your result, tear it down, set it back up, record the result, tear it back down, and actually record the null results when nothing happens. But it's well known that the Cavendish so-called experiment fails a lot.
Yeah, that is what I will be doing.
What happens in science? You generate value. See, it's greater than chance, right? Yeah, I got a shit connection. It's windy as fuck here too. So
all right, you're good now though. Right now, you're pretty good.
So
go ahead.
We generate a p-value to see is this greater than chance. We don't even know. We don't even know if it's just anything because of the amount of failures.
Yeah, that's exactly what I'm trying to get to.
I swear to God, if Cat published this stuff today, he'd never get published.
Mm-hmm. He'd be making toys for kids, for toy stores. He'd be making toys.
Yeah, but that's what I'm trying to get to.
Before you go on, I just want to add a little anecdotal thing to Cavendish, because before Cavendish made all this stuff, he also he was one of the people behind what we call Newtonian gravity, even though Newton didn't want that. He didn't postulate his theory. It was Cavendish and CV boys who pushed it and created it.
He was trying to figure out the density of Earth by weighing it. He wasn't trying to prove that mass attracted mass at all. Yeah.
And his number was wrong because he got the density of water wrong.
He did?
So it wasn't even correct. I think he used a value of 1.3 instead of 1.5 or something.
Okay.
Uh-oh.
Yeah.
So you got the weight all wrong then, huh?
Good 20% off or so.
Yeah, but what I might be converting to you guys if depending on what I find. I do not know what I will see. I might find that.
Bro, go ahead. I'm sorry.
I might find that Cavendish is just like it's random. How many times I set it up, it will just show me a random result, and then I will note that down, and I will try it in a different location, and then I might say, oh fuck, it doesn't change in a different location, and then there is a high chance that Cavendish doesn't work. But if I see that it does work, then it might work. I don't know. It depends on the result.
What does it prove? What does it prove when you get an oscillation in the string or in the torsion bar? And what are you? If this is an experiment, what's your independent variable here? What are you varying?
My independent variable is the distance between the masses.
Distance. Well, are you manipulating the distance between the masses?
Yep.
With what?
I place the masses a certain distance between them.
There you go.
With a certain distance, and then I will note down the acceleration and the speed during the experiment to see how it moves, and then I will do this again with a different distance, and I will continue to do this.
But for pages, for this experiment, can you use bricks instead of metals?
Bricks?
Bricks. I think he said bricks. Yeah.
Bricks. Yeah. I could do that. I will change my my types of materials, because if it doesn't work.
Can you explain? I have a question in regards to this Cavendish so-called experiment. Did he assume that lead has no magnetic properties, or what?
I don't know. I don't know what Cavendish did. Yeah. I haven't read his report, and I don't care what he did.
Do you know
because I will do it myself.
Do you know what lead properties are?
Well, you should care what his results were, what he was trying to do.
Well, I think we should
encourage him
to do his own test anyway. You know what I mean? I mean, that's nothing wrong with that.
What was that, bro? I didn't catch that.
I said we should encourage him to do his own test regardless.
Cut out again. Fuck, you cut out.
How about now?
I can hear you now.
I think he said we should encourage him to be doing his own tests. That's a good thing that he's doing.
Oh, for sure. 100%.
Yes, that's what I said.
100%. Okay.
Yep.
Oh hell yeah, man! Do it. Change the materials. Change your distance. Stay methodical. Stay, record everything, and man, share the results. I would like to see it.
Yeah.
If you get it to work.
The helium balloon.
But it's just as interesting if I don't get it to work.
See if
Use a non-Newtonian fluid. See what happens.
See if a lead ball is a helium balloon.
The problem is when you read literature advising you how to perform the Cavendish experiment, they explicitly tell you that it works the best with iron weights or lead weights, these two metals.
I wonder why, man. How come?
Yeah.
Why does it?
Because they have magnetic properties.
Exactly.
That
Electrical.
might be true.
Might
What?
be, yeah. It might be true, yeah.
Yeah.
Lead
has two opposite magnetic properties in the same time. The lead atom is diamagnetic, and the metal lead, when you have more than two atoms together, it becomes paramagnetic, slightly attractive and slightly repulsive. And because of these two opposite forces, the magnetic, the metal lead, is always attracted to itself.
Yeah.
Oh, okay, check this out, man.
But
I can
that's
pull
true.
up. I have an article. I believe it's from Popular Science, from like 20s, I think 1920s. It was a dude that built an apparatus. He was trying to prove emission theory of light from your eyeball. He built an apparatus with like hanging like metal like foil or something like that. It's inside of a glass evacuated tube, a big jar. And every time you would look at it, you would get motion. You'd get movement. So people really thought it was emission theory. Now I don't know what the cause of the movement is of the hanging metal foil, but it moved.
Yeah.
And it was published in Popular Science. So there's a lot of interesting apparatuses out there, but we don't know how they work. What the cause is.
Yeah. And that's the same with the boiling water thing we talked about earlier. Like we could say we see a cause that it is that we put heat onto it, but it might just as well be that we put heat into it, have a certain pressure, and that we look at it. That it's also observed. That could be a thing. It's hard to disprove, and we might find out it just works on Earth, and then it doesn't work on Mars because there might be different rules on Mars. We don't know because we haven't tried it there.
You'll never be able to either.
Yeah, but like we don't know, and that's one of the most annoying things, that we can't like be certain about anything.
Mars is the imaginary.
Idea is to try. You know what I mean? Try to be certain.
Mars needs women.
Nothing wrong with that. What? Mars what? Needs women? Yeah.
Needs women.
That's right.
Yeah.
So
of course Mars needs women.
Why they don't go to Venus?
That's where you get them from Venus. That's where you get all the hot chicks. Yeah. Pick them up from Venus. You go party at Mars, right?
Send them out early so they can get a head start.
What can you find? What can you find in on Uranus?
It's usually very brown.
If you think about the Cavendish apparatus, man, like by hanging weights and varying the distance between them and observing acceleration, what can you conclude? What if it is the electrical attraction between the two metallic objects that's causing them to come closer together and oscillate?
Yeah.
What are you gonna do then? Because I can do that with electricity. I can 100%. I can pull metal objects together just by using electricity and no magnetism, just the electromotive force.
Right. And
Will yank electrons out of atoms, no problem.
Yeah,
That's
you
how
would have
strong
to,
it is.
you would have to separate that out too. If you were not measuring for that, you would have to be able to remove it.
Yeah, but as I said before, I'm not measuring for gravity. I'm only measuring to see if there is between masses, for whatever reason. It might be the electrons inside the masses, but between two objects, is there some kind of force? That is what I'm trying to see.
That's kind of a problem. If you're trying to determine any outside force, you are not going to be able to manipulate enough to determine that.
Well, that is
That's why
up
I
to
said
see.
non-Newtonian
I might
fluid.
be able.
Non-Newtonian fluids, when force is applied to them, get more dense, become more rigid.
Mm-hmm.
So if there is a force, this oobleck would become more rigid.
Yep. And anyway, a determination of force, you have to be a force is a force because it's shown to be able to do work.
Yeah.
So here's the question: has anybody done Cavendish using different materials, right? So like steel ball and a lead ball, or like
wooden
stone ball and like a bucket of
No,
water.
Styrofoam.
They don't advise doing that.
Dissimilar metals.
They advise
You're
you
gonna
to
have an
use
electrical attraction.
lead and iron. Yeah.
Yeah, but if I
what
have
if
the
things
time,
that are similar properties are just attracted to each other? What if like lead is just attracted to lead, etc.?
Yeah, lead is attracted to lead because of its properties. The lead atom is diamagnetic and
what
the
if it's
lead
an unknown
metal
property?
is paramagnetic. So it always attracted to itself slightly.
hopefully I will be able to test this. But if I have the time,
you don't need to test this. This is knowledge.
Yeah, but hopefully I can see the results myself, and I can see that how it changes between some materials. And
The physics of magnetism already sorted out the magnetic properties of all the elements.
Yeah, but then I can see if it adds up.
Yeah, I just wanted to clear up. I think what Indio's point was actually not to do with magnetism. Just so I can understand from you, Indio. It seems to me like you were arguing that it could be that like attracts like is a separate thing from magnetism and from gravity and from everything else. Was that kind of what you were saying?
Yes, exactly. Like likes like. Did you hear me?
It's gravity, though.
Yeah, I don't know what it is, but
Famous statement by Feynman that that for some reason, if you take water and there's and part of the water is ionized, it'll actually form like a barrier, even though they're supposed to be repelled by opposite charges. It'd be like two layers of protons, protonated water. Yeah, it's pretty nuts.
Oh, are you talking about easy water? Oh, I think I know what you're talking about. But I don't know. It's not.
No,
it wasn't
it's like an
Feynman.
experiment you do if you put water between two charged plates, right, plus and minus. It will actually be a layer. So all the electrically charged water will go to one side, and all the positively water will go on the other side. But between that will be a layer of like charge. When they shouldn't be there.
Okay.
Yeah, I'll find
but,
the post. It's in his lectures on physics. It's pretty crazy.
Yeah, but I actually have to go right now.
Yeah, Pagus,
it was very nice.
Oh, I'm sorry, Pagus. I just want to tell you, I sent you a DM with Brian Mullins from Balls Out Physics about the Cavendish. I suggest you go ahead and watch that when you get a chance.
Yeah, thanks. I'll do that.
And sorry to interrupt your parting.
No worries.
I'm just slightly upset that I didn't get to talk to Pagus again, my old friend. But I hope you're doing well, Pagus.
Yeah, you too. Well, it was lovely talking to you, everyone. And hopefully we'll get to talk more soon.
Yes.
All right, man. Take care, bro.
Thanks, Pagus.
Have a great day.
Nice hearing you today. Yeah, that's pretty awesome. Interesting.
India, what you were talking about with the water, isn't that called like a field or Gaussian barrier or something like that? Can be demonstrated like within a capacitor?
far, I just remember from listening to this lecture, it's him talking about it. I posted a link which talks about it as well. I can't remember what. I think it's the lecture that on electricity and magnetism. So there actually is a webpage for it. I'll try and find that and post it too.
Cool, thanks. I'll take a look.
I heard that song in the background. Reach out and touch faith.
I don't want to know what this is. So there's people riding exercise bikes outside in this little courtyard to this gay music. Here, I'll take a picture for y'all.
Did anybody see I forgot his name. I'll pull it up. I think he had a TED talk about water and the interesting new discovery or whatnot. He calls it EZ or something zone, electrified zone or something like that. Where he made a pretty cool discovery. If you have like I think it was a hydrophilic, but if you have a hydrophilic material like a tube shaped in a tube, you drop that in water will actually start flowing. I think one of his buddies or something was playing with a UV light or something in the laboratory one day. And when the light came across the experiment or whatnot, the flow sped up, right? So anyways, he concluded that UV light interacts with water and anyways, makes it like flow. So in your veins, like your veins are hydrophilic. They're not hydrophobic. They like water. They're not water hating. So just by having like those properties, you'll actually get flow. And if you give it UV light, the flow will increase for some reason, which was pretty fucking cool. I like shit like that.
That's interesting. Is that maybe why UV light can support cancer or help with cancer growth? Because cancer growth strives or lives on the blood flow to the cancer. So the more the flow, the more the cancer can grow.
Yeah. All right. So I don't think I've watched this lecture, but this is the guy, Jerry. Okay, copy link. He calls it the fourth state of matter. I'm sorry, of water.
Yeah, that's in the same website, isn't it? I just saw that. Semantic Scholar, is that you're looking at the same thing?
No, I'm on YouTube. I know the guy Pollock or whatever his name is. Yeah, I've watched this lecture, or we'll watch a lecture about his work. Like, I don't know, 5-6 years back. So I haven't seen this one because it was posted 2 years ago. But his discoveries are pretty cool, like water-based batteries and shit like that. That's where like his research can go.
Yeah, I heard about this years ago. I'll definitely watch this.
Yeah, man. Let me see if I could find something shorter. That's not an hour long. Yeah, here, the TEDx talk. Let's do this. Share this one. A lot more views and a lot shorter. So why not,
like
right?
them longer. The more.
Oh yeah, the nerdier fucking videos. Yeah, once you get hooked, yeah, you're like, where's the 3-hour lecture at?
Yeah.
But this one is decent. Like, yeah, it's pretty cool. Mainstream published shit, so it's nothing, on the fringe or whatnot.
I don't know. I'm just rather astonished at we're in modern ages. We've talked about high-speed interferometry. We've talked about over 100-year-old testing that was done with interferometers like the Michelson-Gale, Michelson-Morley, Sagnac. And I just, it eludes me why we have modern-day folk with supposed modern-day education coming here talking with us about sticks and shadows and parlor tricks from the 1700s. I'm flabbergasted.
I like that. Are you talking about Cavendish? Parlor tricks. It has to be Cavendish, bro.
It is parlor tricks, man.
It is, man. I agree, dude.
So what are you going to be determining with that apparatus? Oh, mechanical phenomena. Great. That's not in the realm of natural science. So have fun with that, whatever you're doing over there, playing with your toys.
I mean,
what are you doing?
I'm cool. I'm fine with that as long as like your outcome is legitimate. You know what I mean? Like it's directly correlated to the whatever it is that you're observing, right? Or the effect.
Yeah,
that's fine.
It has to have a cause and effect relationship somewhere. I mean,
like I said, man, I like the emission theory stuff back in the days. Like it was cool stuff, you know. It's interesting. Look at people built, you know, apparatuses and shit too. So you'll find a bunch of weird apparatuses that do shit. Doesn't mean that, you know, we know how it works.
Right. Like you can take an apparatus that's turning and then turn it into a reciprocating motion. So why does that happen?
Because you have a crankshaft that turns linear motion to circular.
It's a mechanical phenomenon. That's it. That's what it does. It's actually, that part is not a phenomenon. We actually know the nuts and bolts of why mechanics work. That's how we can use them so well, right?
Yeah.
Can anyone think of any kind of, well, let's see. I might be missing something.
What?
So what can you determine from mechanical devices? Is there any outside force that can be determined with mechanical devices?
What's the device and what's, like, you know what I mean?
Well, I'm just leaving it wide open. I'm just anywhere. Is it possible to do with any kind of mechanical device to determine an outside force? You can measure outside force, but can you tell what an outside force is? I don't think so. Not with a mechanical device.
What kind of force? Like electromotive? Yeah. We have actually galvanometers, named after Mr. Luigi Galvani. He used frog's leg tissue, like muscle tissue, as the electrical detector. You know, and you can just walk around and detect the different electrical activity in the air. And whenever you have thunderstorms, shit just starts flopping.
Wow.
The needle.
I never heard of that.
Oh, dude, Google it. Galvanometer. The first voltmeter ever. You know.
I've heard of that name, galvanometer, but I didn't know that's what he was actually doing.
Dude, Luigi Galvani, man. Started all this shit.
I'll use frog legs.
Yeah, because that's what he noticed, right?
Who would have like?
You know, the frog's legs, like during electrical activity, like thunderstorms, they would actually move on their own without him like dissecting them, touching them. So he's like, okay, all right.
Something going on there.
Ghosts. Yeah, we got ghosts in the frog, which is electricity.
Mm-hmm. I don't know.
It's interesting because you can conclude from that alone that muscle tissue will respond to electrical stimuli at post-death. Like your muscles will still respond to electrical stimuli, which of course has nothing to do with the realm of like, you know, what he was after, but that's something cool.
Mm-hmm. I'm more talking along the very thin, razor thin line of force, like
F equals ma. What's force, man?
What do we determine force with? How do we determine force? By the work it can do, right?
Pressure, like so, which is force divided by area.
Buoyant force, yeah. There's one. I don't know. I'm just kind of spitballing here. You know what I mean?
Yeah. I don't mind Newtonian mechanics, so I like it.
I mean, you can take a helium balloon, you put a big enough helium balloon with enough helium in it, it can lift thousands of pounds, right? Tons. You know, the same thing with the buoyant force. You put balloon with air underwater, it can lift things off the bottom. Hundreds of tons. Ships, as a matter of fact. Lift them right off the bottom with balloons. So, no, the Glober's always coming in as why does it go up? Why does it go down?
Man, honestly, it's a cool question, but it's a question of like polarization in my mind. Like, why is it polarized this way? It's like, fuck, man, we found it this way. Like, we really did. Like, So that's hard to explain.
Yeah, we just see it here all set up, working the way it does. I mean,
Magnets. Wow, why does the north pole of a magnet attract the south of another? You know what I mean? That sort of shit. It's like, I don't know, man. And it's always towards each other. You know what I mean? It's like, I don't know. What the fuck? Why doesn't that change?
A lot of a lot of things with electricity that are very odd too, right? Yeah, you could ask lots of questions. Why does the current go positive and negative? And then we have cases where in vacuum tubes it doesn't. Electrons flow the opposite way. Through my guitar amp, it goes the wrong way. AC is flowing opposite direction, away from negative towards the positive, all the way out through the speaker transformer. Wrong way.
Well, AC or a sinusoidal wave is just it's a circle expanded, really. If you know what that is, it's a what is it? Circle or what was it? You studied it in geometry. It has a name. All it is just you're plotting out where you are in the circle. You're taking the sine of that angle. That's why it's called a sine wave. There's also a cosine wave, right? Yeah, it's like there's a sine wave, cosine wave. It's just it's a mathematical plot of a circle, pretty much. Really, it's a circle expanded. That's how I understood it. I did well with that understanding. Like I aced all my classes, so it's fine.
So how is it possible that a smaller AC signal can be traveling from negative to positive against a high voltage DC current going from positive to negative? AC flows in there and flows the opposite direction.
I've got no idea. Ask Nikola Tesla.
Exactly.
I don't know shit.
I'm not an electrical engineer, but doesn't charge always flow opposite of like your current? Like you have a directionality to the current, but then the charge flow is always opposite of that.
Yeah, but by charge flow, you're not exactly talking about interjecting a AC current into a vacuum tube where there's already up to 400 volts DC, positive to negative, grounded. Then you interject an AC current, it flows the opposite way. I've never heard any good explanation why, but it does happen.
Yeah, don't. Explanations in electrical realm I shall not give at all.
Good idea.
At all. Zero.
Idea. That's like
100%.
saying because it can't be determined because honestly, electricity is just like the sun. We don't know actually what it is. We have no idea.
But it's like works. You stick your finger in the socket, shit will kill you. Like you don't have to speculate anything. Touch it and see. Touch the invisible stuff. See what happens.
Yeah, we definitely know what it can do. Yeah.
Crazy, man.
But we don't know where it came from originally.
I don't know. You can say it all comes from the sun.
From the
sun worship.
All electricity comes from the initial source.
Comes from the one. Sure. Yeah.
Well, there's an energetic basis to everything, right? Like all matter is comprised of different varying charged particles, right? So, or various charged potentials. So everything is really energy.
What is energy? Yeah, I know. Yeah.
There's another one of those unanswerables.
Yeah.
I feel like the realm of energy is where you start to blur the lines between the physical and metaphysical.
Absolutely. We can only kind of get an inkling of this, though. We've never really been able to touch it.
I think electricity is like the bridging gap in my mind. Like, okay, if we just use thermal energy, heat, okay, just to make energy simple for us, okay, unit of heat or a quantity of heat, okay, cool, or an amount of heat or whatever. Well, it's not true because it's the amount of energy or whatever. If you think of it this way, then electricity bridges the gap because with this invisible stuff, it carries energy in it, and I can transform the energy into like heat, mechanical, like motion, whatever I want. So electricity is like the true other side for me. It's like, fuck, we work with the stuff from the other. We don't know what the hell it is. We don't know what it is, but we can manipulate it, but we don't know what it is.
Yeah. It pops its little head out here and there. It's like the physical representation of something, of all these invisible things. That there's a couple things that we can tell what the effects are. Like they are causing effects in the physical world, but we don't know the initial cause of
like
what.
back in the early days, when they strung up the AC system, alternating current and whatnot, and they were trying to work around Tesla's patents, shit was just blowing up because it was Steinmetz that found this out. There were transient waves, so there was electricity of different forms that hop into the grid, and we can't see them because they come in and out. They're frequencyless. They don't have a frequency. Wow. So, and they would hop in and out, and they would like, dude, with DC, and this was common on DC ships back in the days, and a lot of people got blasted. Once you close a circuit and you're flowing a lot of power through those DC wires, don't you ever dare to open that fucking circuit because it will keep going. You open that circuit, it's gonna arc, and the arc is gonna get bigger, and it's gonna blast the fucking hole into existence somehow. Yeah. So when you do that, electricity just comes out of the ether from nowhere and just, it's like, all right, let's hijack the system and blow it the fuck up.
That's
and
amazing.
Shit was blowing up everywhere, man.
Yep. Yeah, like even like it'll go through your arm and come out your elbow, you know?
Yeah. You'll be the shortest path. Like, oh, thank you, sir. You're shorter than the air, so let me grab your arm right here off the knife switch, and off we go, you're dead. Boom. Done. Yeah, DC's interesting. A lot more interesting than AC for sure. Well, like high voltage pulse DC or chop DC or whatever you want to call it is very interesting.
Pretty wild.
Not to get too much into the metaphysical, but the terminology always reminds me of biblical stuff as well, like archangels, right? Energy arcs. And there's always the search for the Holy Grail, and it's described as a chalice, which would be something similar to a hyperboloid, which is the inverse of a torus. And we know that magnetism flows in a toroidal field, and you have the inverse of that, which is the hyperboloid. I don't know. These are just weird things that pop into my head when thinking about electricity.
Oh, no, the conic section does come into play for sure when you're talking about electricity. 100%. The hyperbolas and all, they're all conic sections. No, I love electricity. I've been trying to understand that stuff ever since I was a kid. Why? Because, almost died from a 400 volt capacitor, aka condenser, that I didn't know was a capacitor at the time. So I was just a 10-year-old child taking shit apart. And zap! All right. Shit gets serious, So I let it go for a little bit just due to fear. And then came back with an education. Like, all right, gotta know what just fucking almost zapped me out of existence. Like, what is this stuff?
Good thing you made it through that experience.
Yeah, dude. I was a small kid. Like, it just might, it was my physical size was like just a 10-year-old kid, you know. So 400. Lucky me, it was a small capacitor. That's it. So I got a lot of voltage and decent amount of joules, you know, pretty quick. So it hurt a lot and it thumped right in my chest. But luckily, the capacitor wasn't big enough to deliver enough joules to kill me. Voltage is definitely there, more than enough volts to, you know,
high voltage, low amperage.
Yeah. Oh, it's actually, so the amps. That's the thing about capacitors, because you can discharge them in such a small amount of time. So you'll have a peak discharge. So, okay, think about it like this. Now, this is where we need energy, because amps isn't enough. We need this energy concept. So if you have a battery, okay, like a voltaic pile, you know, a DC battery, 12-volt battery from your car or whatever. Let's say it has heat energy. So we'll say it has 10 cups of energy inside or whatever. But due to the resistance of the circuit one, I could only deliver it if you short it. So if you just go with zero or like zero resistance across and you short circuit the thing, it could only deliver so many amps per second due to the internal resistance of the circuit and all that. Capacitors, no. You give it a perfect conductor, and theoretically, if it's the perfect, theoretically, you can't do this, but theoretically, it will dump it in such a small amount of time that T approaches like zero. Time approaches zero. But that's, of course, that's something we want to achieve in the electrical realm, but, you know, it's hard to do. It's hard to dump something in zero amount of time. It's impossible.
Right.
But anyways, that's an impulse electricity shit. And that's the sort of current that flows through your nervous system. It's impulses. It's like a train of direct current, but they're pulsed. It's like a pulse, and a pulse
like
train that has a frequency.
Dots
You know what I mean?
and dashes. It's almost like
Yeah.
zeros and ones.
Exactly, like that.
Yeah, that's such a trip, man, because people don't
actually
think of themselves as electrical beings like we actually are, and we're receiving all these impulses. They're being turned into something else that causes us to make actions with our muscles, which are physical, you know, like biological parts of us being controlled with this electricity, which we have actually a lot more control over it in ourselves than we think we do, because we've never been taught about electricity, really, you know, like how it lives it's in us also. We've never been taught how to like manipulate, or what, I don't know if it's manipulate, but I think we actually can manipulate the electricity in our bodies.
So it's about my analogy. Go ahead, bro.
I got a question for you, Cyrus. So, what's the speed of propagation of a change in potential difference?
The speed of propagation? Oh, I don't know. No way.
Neither do I. Neither does anybody else.
That's the work of Steinmetz that no one finished, right? According to Eric, that's what he said.
Yeah,
like the speed of propagation of the magnetic field has never been determined outside. Like, you know what I mean? When it emits out of the wire, nobody ever.
The change in the static field has never been determined. It's the speed of that change. Like if I have a capacitor. Like say I was like, you know, I had a giant capacitor, and I changed the charge on one side of the capacitor. How long does it take for the other plate to feel that change? This has never been tested. Like,
I see. Yeah, no, fuck.
According to Gauss's law, it should be instantaneous.
Yeah, it appears.
Gauss's law has no time in it.
Okay.
Yeah, that's really.
So you can also there's actually a paper written on this where this is kind of like the thought experiment, right? So you have a copper sphere, right? But it has a hole in it. And you shoot an electron through the hole into the center of the copper sphere, and it hits the inside, right? So the charge that's on the surface which should change instantaneously, right? Because the conservation of charge.
Okay.
So theoretically, the speed should be instantaneous. There should be no speed of light or anything like that. And I think this has some relation to the longitudinal wave theory. because transverse waves, they're transverse to the direction of travel. So you could think of that, as Dollard said, as like a drag through the ether, right?
Mm-hmm.
But the longitudinal wave, there's no drag. And I think the longitudinal wave is connected to the voltage potential. Like there's like imaginary rubber bands connecting electrons to electrons.
Right? Faraday tubes. Yep. Or the lines of force. Jason Thompson. Yeah. Yes. Exactly.
Yeah, and there is no delay between. This is. Wait for this. This is like a social rabbit hole. Electricity. It's crazy.
I love it, man. It's, dude, like Dollard said, whenever there's a new discovery in this realm, my God, like there's big consequences. Always. You know, it's insane. Electricity is it's fucking interesting, man. For sure.
You guys were talking about that guy was on the other night about the satellites, ionosphere, and all that stuff. And you guys have been talking about that for a couple of days. I wanted to chime in, but I didn't really want to get into it because sometimes I'm just not in the mood to get technical. Still not in the mood exactly, but plasmas exhibit negative refraction. So listen, yeah,
okay,
so they bend away from normal, and that's not the only property. The phase of the wave can actually be superluminal or subluminal. So it's like I said, it's so technical. I don't want to get into it because I mean it'd be like a 30 minutes just to tell everybody just so they fucking get up to speed on what the fuck I'm talking about. But this is like, I wouldn't say it's well known, but they've known it when they first came up with this ionosphere theory, right? Of course, the military came up with it because that's the military always coming up with the communication stuff first. But it's vital to war, right? So this is what they came up with. Like this isn't what this has. If the Earth's evolved, this is the only way this can be happening. So yeah. So even though they had no examples of negative refraction existing, this was their excuse to how radio waves could propagate around the globe. And I wanted to bring it up but the thing is, you wouldn't. The point is this: you wouldn't notice like a signal degradation or anything, because you know how you can look in like a certain type of lens, and the object will look further away than it really is. You would get this same type of effect. Like you would have the signal loss as if it was 1,000 miles away, even though the transmitter was 50 miles away.
Okay.
Because the focal point is in a different location. Because of being refracted, it changes the apparent position.
Yeah, dude, that is sophisticated shit. Now we're getting.
I didn't really get one into it that day with that guy. But let him believe what he wants to believe. I don't really. Sometimes I just don't care. Like, let that satellite do it, believe whatever.
Oh, dude, I feel it, man. Sometimes, like, I just hop on here, got off a fucking 30-foot ladder. It's like, I'm not gonna argue anything right now. I'm just gonna chill. Like, fuck this.
That's why Pagus is like, I'll convert. Like, and I heard you say like convert. Like that's to me too. It's the same feeling, right? It's like fingernails on a chalkboard. I'm like, what? Like, no one's trying to convert you to do anything.
Right.
I'm trying to give you information. You're welcome.
Yeah, exactly. It's like convert, man. It's like, I hate that word anyways. People use it with like religions too. I'm going to convert. It's like, bro, you can't convert. You're a human. You can only converge or diverge, man. Become one with or away from. You know, that's it.
That's the whole thing, because they actually, even unwittingly, they know they're actually living in the realm of belief only. So they're talking to us in language that's relating to belief systems.
Yeah.
Yet they deny that it's a belief system. When we tell them that it's religious, what they're doing, they'll deny it at all costs. They'll hold on to that it's not for dear life. which is what happens with somebody whose belief system is being threatened, and they're being they're stubbornly holding on to it beyond any proof or anything like that.
Because the atheists think that they think that if I don't have a belief in a supernatural being, I am Ubermensch, because science is the highest form of knowledge, and because I don't believe in God, I am one of the highest beings that ever existed. They don't even realize that they actually have a belief. It's crazy to me. It's just crazy. It's so funny. They don't
They'll say that, and then out of this other side of their mouth, they'll say that science doesn't prove anything.
Yeah, exactly. It's so funny. People are walking contradictions.
Yeah, man. I tried to not do that, man. It's tough. You know, you got to really watch yourself. It's like, all right. That's part of being like, I could call it just honest or whatever you want, woke or whatever the fuck you want to call it. Just be honest with yourself first. Don't lie to yourself. You know, have you ever seen curvature? And you know, when I was like, I know I said this a lot, yeah, because I've flown a lot. I was like, yeah, I've seen the curvature on a plane, but however, did I actually see curvature, or did I just parrot what I'm, supposed to say? It's like, yeah, I did actually. I never saw a curvature. I never even tried to measure if there was curvature there. So how the fuck did I determine that I can see curvature? Huh? You know. And then it's like everything starts to click. It's like click, click, click. It's like fuck.
You can't trust your senses, but I saw curvature from an airplane.
Somehow. Yeah.
Can't trust your senses, but you can trust random strangers on TV saying they went to the moon.
Well, their senses are better than yours, Indio, because they're professionals. They have. Well, you're not as smart as Tom Petty. I can just tell you that. You know. You don't have duct tape and did you see his invention, his patent, his coffee cup, his space coffee cup.
Chugga, chugga, chugga.
Yeah, dude. So you can drink his chugga 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 in the morning. Oh yeah, the capacitor thing. Okay. I remember again. Better example, or okay. So if you have a cup of water that you're trying to boil, right? And we're going to go two ways. We're going to boil it with like a cap or whatever, or we're going to boil it with a battery. So you need the amount of joules you need to raise it from ambient to 100 C. It's going to be the same, right? However, there's heat loss and whatnot. So the time you deliver this to the water, well, it does actually matter because heat transfer needs time for sure. It's not instantaneous at all. So check this out. So if I have a heating coil, I hook this shit up to, whatever, battery, measure the current, I know how many watts, which is how many joules per second are flowing through, boom, cool. So now I charge a capacitor with the same amount of joules. However, let's build a theoretical heating coil that has no resistance, right? And theoretical for a reason. Now if I dump that capacitor, theoretically, it will dump all of its energy at once. At one fucking shot, it will deliver it, which will just make the wire, the coil, just explode. Just boom. Because the delivery time was so short and the energy was so high, it just turns into vapor. Shit just turns into vapor. Metal just turns into vapor when you do that. Just boom, instantaneous, just vapor. It's like, holy smokes. Because it's just the energy delivery over time is so high, it's insane. Shit gets blasted out of existence. Cool. That's the difference between capacitors and batteries, condensers and batteries. It's just they go at once. If you have the right, if your resistance is low enough, it will dump everything at once. Batteries, no, they don't. They have internal resistance, right? It's high, so
that's why your skin and your body is such a problem near those things. Like if you touch that one contact, that's it. That's an open circuit to that charge, that potential.
Oh, I keep my big ass capacitors shorted all the time in storage because they can't just get charged from the air. Oh, I short them, buddy.
I
I
double
mean, I
check
play
it.
no games with caps.
I make sure they're zero. Yeah, I have some pretty
Yeah.
hefty ones in my amps here. Yep.
Oh yeah, they'll give you a nice jolt, bro.
I've never been jolted, except one time I was untying my amp and I had a bungee cord and I let it loose and it went whack and it broke one of the tubes and I thought I heard it break and I don't know, my instinct was like stick my hand in there. I don't know why that was the instinct. It could have been really bad. All I got was a little zzz, just a little tingling. I'm like, holy shit. That tube has a lot of power. I mean, it's got 385 volts DC running through it.
Yeah, you don't want to touch that, bro, and plenty of current to kill you, so you don't want to touch that.
I don't know why. I must have touched the grid or something. I must have
you don't want to touch that.
Instead of the plates. If you touch the plates and there's it's going right to ground. Hopefully that's not going through your heart region. That's why they say whenever you check it, you put one hand behind your back in your pocket and you only work with one arm.
You know the superconductors, how they when you cool them down in liquid nitrogen or liquid helium, and they float on the magnetic lines of force, right? And so theoretically, if you have the perfect conductor in the world, right, which is something like that, right, which we don't have, but even better, if you have the perfect conductor in the world and you have current flowing through it, so you have magnetic fields, right, magnetic circles around the wire, right, because you have current flow, right, some device attached or short. Now, theoretically, if you were to take that wire and loop it onto itself, creating a circle, right, just right, magically, of course, this is theoretical, the magnetism would be trapped there forever and not get chewed up by resistance. So you would trap physical jelly, this magnetic jelly that we all played with. It would be trapped between just a piece of copper that does not exist, that has no resistance. So that's, I don't know, I hope you guys because
I kind of do. It's
magnetism is a concept of it's an archetype of space. You need physical space to store it. These magnetic force, but the electrical lines of force in a capacitor, like capacitor is just two pieces of metals, separated by a dielectric. So two conductors separated by a dielectric, something that's not conductive. The thinner you make the dielectric, and that's where the storage is at. The thinner you make the dielectric, the more charge it can hold. What is it?
That's counterintuitive.
The conjugate. Yeah, it's a conjugate to magnetism, right? It's the opposite. It's the one denies the other sort of thing. You know what I mean?
Well, this gives me some really good ideas. Listen, because we're traveling through ether, right? When we're moving around, so like I ride a bicycle all the time. So I've often thought, well, why can't I capture? There must be some way of capturing this. And I've had these different, like I've had little dreams and visions of how this might be done. I don't know why. Dragging a little copper sled attached to a copper wire. What if I had some kind of screen going through the ether as I'm moving? Shouldn't I be able to capture some charge?
I think NASA did that, but I'm not going to believe the results they got. They did it in like, I don't know how high up.
I want to power the bicycle with that. That's what I want to do. Well, and then I want to make it fly.
Well, I don't know if a copper plate will do it. You're going to have to build. You're going to have to invent some shit, man, on some new level.
I know.
I know.
I know. I'm not worthy. I don't know enough about the technical aspects of it.
Experiment and see.
That'd be some cool stuff to test around, though. Like maybe
they did space tether or some shit like that. Tether. NASA did some horse shit like that to see if we can create charge or whatever.
Well, there's obviously a potential, right? So if whatever you have is continually grounded and you have something going out into the ether, I don't know. That's just as far as I've gotten.
the furthest like I've gotten, I mean, J.J. Thomson, the Faraday tubes. I subscribe to that. I just like that theory.
Okay,
I prefer, and it works just fine. Same, you know what I mean? It works just
okay,
fine.
good. So help me build the apparatus.
Oh no, that's I have to go to J.J. Thomson or something like that. I like vacuum apparatuses myself. This is where I know this is where like this is the research that has stopped in the vacuum apparatus world, and we went because we went silicon, okay. And now, so there's a lot of in my belief, and this is 100% speculation belief of mine, there are many tubes that have never been invented yet. It's like, we don't know yet. Because vacuum tubes can do a lot of fucking shit. Including give you images. So, yeah, it really can. Like, you know, the cathode ray tube. So, you know, it's an interesting little device that when you read old, like, Eastern mythology, it describes a lot of the demons or whatever they describe from the other realm. Because there is this, they have this saying, you know, a blue demon in a bottle. It's like, excuse me, like I know exactly what that is.
The
it depends if you got argon or if you got an inert gas in your vacuum tube. It depends on what gas, if you know, is in there. Will give you like reddish glows, blue glows. You know, if you want a blue glow, just stick some argon in there.
So you think the genie might have been talking about the genie in the bottle and the electricity?
Plasma. Yeah, exactly. Electricity in a bottle, vacuum tubes. So,
what about the flying? What about the flying carpets?
I also believe in that. Yes. And the only reason, look, bro. Look at the discovery. look at silicon, and look at the internal combustion engine. Please, bro. Please. It's fuck, man. It's 300 years fucking old. Whatever the internal combustion engine is, piece of shit. 20% efficient garbage. Rockefeller.
I'm fully with you there, bro.
Yeah.
I totally.
Yeah, I know. So what if Rockefeller never existed, or not this way, and the research in this field was open? And I don't know. And the electrical research was also open. It's like, or a lot of money was spent in, like, you know, funded towards that.
Yeah.
Maybe we will have a small little thin, like whatever piece of like 2 foot by 4 foot piece of plywood in the beginnings where you stand upon it and it will take you places electrically. And this is my belief would not be heat. Of course, that's a heat device, but not from gasoline or not from, you know, these fuels, liquid fuels. It's powered by electromotive forces.
Yeah.
That's my belief. Yeah. And just a belief. Speculation shit.
Well, you know, there used to be many dozens of small companies and shops here and there throughout, even just in America, but all throughout Europe and as well. In the early days of automobile, were manufacturing automobiles with different types of motive force, you know? So electricity, steam, there was different things out there. So there was lots of different things being done. Then all of a sudden, boom, there's only like 2 or 3. Eventually,
steam is still more efficient than gasoline. Still. Always was and always will.
Yeah. So is diesel, quite a bit more. Plus, if you can run peanut oil in it or banana or throw bananas in there, like almost.
Because it's not exactly because it's not a diesel engine. Look up the patent. It is not the dude is Rudolf Diesel. That's the dude.
Yeah.
He invented a multi-fuel engine. Oh, okay, thank you, sir. Diesel. He said put any fucking oil in there, it works. All right. You know, because it's compression ignition, not spark ignition.
Yep. So that's a good way to do things. I mean, why aren't there like these small, efficient diesel engines could be running?
There are
everywhere. Yeah.
They're just they don't come out. They're always in research phase. Like I said, I think it was Mitsubishi, and that was when I was back in college. That was more than 10 years ago. Mitsubishi had a 40-to-1 compression diesel that was, I forgot what the efficiency was, but it rivaled that of turbines. I was like, damn, a diesel engine, and because turbines are really efficient because of the speed. You need the RPM. You need speed.
I mean, and then if you had combinations between steam turbine and diesel, like it's almost unlimited there. Charge batteries, like.
So the cool thing about gas turbines is most of them in most power plants, because like the curriculum I studies is actually more towards, in Europe they call it energy engineering. It's not a, so it would be like a mechanical major in energy, more towards the energy realm than the heat energy, right? So all the turbines you can run, most of them are configured in power plants to run on natural gas or diesel. Just if something happens to natural gas, they can always flip to the diesel. No, just flip the valve. Nothing fancy. You know, so they'll run also on multi-fuels, you know, and if they can run on diesel, you know, kerosene is also an oil, and that's what they run for aviation, or on A1 kerosene, if I'm not mistaken. You know, aviation fuel or whatever you want to call it. It's just fucking kerosene in my world. Look up the calorific value; it's still kerosene. You know, like that's it.
Yeah, it's a fascinating topic actually.
So I like both, man. Like I like heat and the conventional sledgehammer approach to the world, where they just burn it to get work out of it. But I also believe in other methods that are better, cleaner, more efficient, and they all belong in the electrical realm, which kind of got chopped, you know.
Yeah, so I think there's amazing things we can do with magnets and coils and.
There's a story out there with Tesla, right, and his Pierce Arrow, his car. However, it's a story, so I think it's the first time I brought it up, or maybe the second time I ever brought it up on the server ever. The story goes like he had a box full of like 12 tubes, and he took the batteries out, or whatever he put an electrical motor in his he took the engine out, he put electrical motor in there, and he had a box of tubes, and he powered it off the ether, supposedly. He took it up to 80 miles an hour. Back in days, that's unheard of. 80 miles an hour. Yeah, that's pretty quick, man.
This is Tesla's Pierce Arrow.
You never heard that story? Dude, yeah, just Google Tesla's Pierce Arrow. Let's see what comes up. However, it's a story. Like the car, where's the car? Right? There are stories around that shit too. It's like, where's that fucking car? Because the keys in the circuitry, like, what's in that box? How did he configure these tubes? You know. There's another story about him putting light bulbs in the ground and lighting them up. Well, I would say that's true. I've never witnessed it. However, based on his stuff and the stuff that he was working on, then yes, that means like he concluded his work, and yeah, you can just the monopolar thing, right? You just stick it anywhere in the ground and you can extract power, because he's transmitting it from somewhere else, you see, and he's using the earth to amplify it, supposedly, right? That's what he wanted to do. But the thing about him lighting up a field of light bulbs or whatnot, yeah, he used to do shit like that. He'd go on stage and light himself up and shit like that. Like he did actually stuff like that back in his day. So I don't know. That's another cool story where, you know, you can go really far away, because you can do this electrostatically today. Fluorescent light bulb that's burnt out is not burnt out. You can still ignite it using field emission or cold cathode, but you just have to up the voltage quite a bit to get to the field emission, right? Because they're all hot cathodes, you know. So call it field emission stuff. Anyways, so with that, you can create a strong electrostatic field, you know, off a coil, and it'll ignite the light bulb using the RF. However, it's very close. It's right around the coil or your high voltage apparatus.
This stuff is wild, because it sounds like did you say RF?
Yeah, RF also ignites plasma. Yes.
Yeah.
Correct.
So RF to voltage conversion. We can do that. Huh?
Oh, yeah, like radio. It's the propagation. Exactly. Like you can take the radio that's coming from the 50,000 watt transmitter, However, it's so far away, so you can't really extract power, but you can.
Right.
You actually can. It's not that much, but you
if we
can.
amplifying it, right?
Now, if you're right next to the fucking amplifier, I mean the transmitter, no, that's a different story. You can
No,
you can really suck some juice off of them.
If you're far away, you could amplify it, right?
Well, amplification is you taking the signal, pumping power into it to make it bigger, and sending it out the other side. So
yeah.
We want to know. We want to harness it. We want to suck it. Like we want to absorb it. I don't want to absorb the signal, then pump it myself, because that pumping you're paying for in units of heat, for sure. Gasoline getting burned somewhere to amplify anything.
Yeah.
So, yeah, you know what I mean. So it's like, okay. So Tesla was on some other shit, for sure. Some other shit. It wasn't RF like that, no. Sorry for the Tesla talk. Didn't mean to kill the chat.
It's okay. Just a lot of that, what you talk about, is over most of our heads. It's over my head, but that's okay. I understand.
No, man, it shouldn't, man. Why?
No, I understand the concepts.
I don't understand it either.
I mean, like some of the things you talked about, I have never delved into, but a lot of the basics I have. Like
it's Tesla, bro. The stories around that guy are interesting.
Yeah.
And like that's one thing I haven't achieved yet, and I will, but let me get better equipment. He noted that in field emission, the cathode and anode, one would heat up, one would refrigerate. So I'm yet to get condensation built up on my anode. So that's one thing I want to achieve. Like, okay, let's do this. How the fuck did you do this? Right? Because that's an effect he noticed. Bro, play with any hot cathode tube all day long, you're not going to get that effect. It's actually hot. It becomes hot. The whole thing becomes hot. Like, so he noted, no, one would get hot, one would get cold. One would refrigerate. Like, oh, okay, Mr. Tesla. Did anybody else notice this too? It's like, I don't know.
So I'll read this from his article. It's about his car. So in his 1901 patents, patent 685, let me read it. 685957 and patent 685958, Tesla discloses a natural cosmic energy collection method and an artificial one in which vacuum tubes were utilized to produce high voltage electrostatics plus a small electromagnetic field flow. From other reference documents related to the car, we extrapolated that in the Pierce Arrow 12 vacuum tubes were utilized. There were 9 tubes of an unspecified type and 3 tubes identified as 70L-7GT tubes. A small electromagnetic field flow from the 3 70L vacuum tubes. The integration of the electrostatic with the electromagnetic flow from these 2 types of vacuum tubes is accomplished with a converter unit as a part of the conversion system. The special vacuum tubes described in Tesla's 1901 patents were called X-ray tubes, which is a misnomer since they were actually electrostatic tubes.
Hold on. What's the patent number for that? The X-ray tubes? I'm sorry.
It's either 685-957 or 685-958.
685
957
957.
And
Okay.
958.
958. Thank you. Okay, cool.
And so the tube is a 70L-7GT.
70L-7GT.
Yeah, 7GT. And so the other one is unspecified, which we don't have information about. So the last part of this is they utilized only polarity into an anode terminal, which is directly connected to a hemispherical aluminum emitter with one end of the tube. An electrostatic beam is emitted from the opposite end of the tube. Wow, that's some weird shit. Wow, that's a trip, man.
I'm telling you that I've been looking for free energy for more than 10 years. So it's like when I read these stories, like I was really hooked, man. When I was a kid, I was fucking hooked.
Pretty complex.
It was like, it's like, okay, it's like we were that advanced 100 years ago. Huh? Why did we de-evolve?
Yeah,
our technology.
We got so dumb. I know the technology got better and better and smaller, but we got dumber and dumber.
How could like Edison and Tesla, just a couple other guys invent all this, or everything that we use today? It kind of fucking sucks.
Yeah. So what did they know that we don't? I think a lot of that information of what they knew to work with has been removed.
Why are we so fucking dumb, man? That's because. Like, you know what I mean? Like, obviously, I'm born today. I'm alive today, not in their era. So it's like, fuck. What the hell were they eating? What were they eating? Those guys, they were just on another level.
We certainly have evolved. We live in a slave system.
People that lived during the Victorian era are probably the smartest people that ever lived.
Yeah.
They were fucking. I mean, you could just go down the line of things that were invented at the end of the 1900s, beginning of the 20th century.
Crazy, man.
I mean, just pick something. I mean, just randomly pick some so-called technology. The people were freaking geniuses, like beyond. Have you ever seen that test, that 8th grade test? It's like an 8th grade graduation test. Like, listen, I mean, dude, it's so hard. Like, it looks like ridiculously hard.
Okay, all right.
There's like a video on YouTube of a chick that's like going for a PhD in mathematics, and she can't even fucking do it.
Damn!
Hold on.
Wow.
Hold on,
okay.
I'll show it to you. Yeah. Hold
on. My god. Okay, it's that bad. 8th grade? What do you mean, man? So the education system really did de-evolve, huh? The devolution of the education. Yeah, man, everything was invented then. All the fluid mechanics, the thermo, it was all during that era too. It's like all the smart people lived then, man.
So this guy named E.V. Gray in 1973.
Oh yeah, Edward Gray.
Edwin Gray, yeah.
Yeah.
So it looks like he knew a lot more. It says in the
article.
motor.
Or
yeah,
did he?
He had his own motor. When he only used 3 tubes.
All right, bro. You want the best guy, in my opinion, out of all of these? You like free energy? All right, you can actually. We got pictures of this shit running. Okay. T.H. Murray. Thomas Henry, I think Murray. Just T.H. Murray, Morray. Bro, we got pics of him with his fucking apparatus, all right? Standing in the street, lighting up dozens of light bulbs that are like 250 watts a piece off an 80-foot antenna and a box. And it's been verified he had no batteries, no capacitors in that box. Oh, no, you should read his story because he's got patents and he's documented. He's in the 1930s. He's in the 30s. Of course, his lab got shot up and shit like that. Of course, got burnt down, research stolen. Of course, but he got somewhere. He got somewhere real good.
Wait, how do you spell that last name again? M-O-R-R...
A-Y.
M-O-R-R-A-Y.
Murray. Just put T-H Murray. See what comes up.
Can I relate it to anything in particular? Electrical something?
Just go on images, bro. And
How about device? There we go. Let's try
sure,
device.
go images, and you'll see him with like a panel of bulbs.
Oh, here we
on
go.
the street.
Moray valve, got it. M-O-R-A-Y. I found it. Here we are.
R-A, okay, just one R? Okay, cool.
Here's a diagram. Trippy. Wait a minute. Save file. No. Let's see if that's a dead link or not. I'm finding so many dead links now. It's amazing.
Wow, man.
Okay, this one
I read this stuff a long time ago.
Forum. Go. Radiant energy device.
Yes.
Free energy planet. .biz.
He's got books where I have his books, and I think I posted them on the server in the section below, actually.
Oh, wait,
the Sea of Energy. Sea of Energy, I think, is one of his books.
Yes, I just passed by.
Yep.
I swear to God, like I'm reading something and you mention it. I'm reading something. And you
Yeah. You're a water sign, if I'm not mistaken. So am I, so you can transmit thoughts easily. That's my theory on that.
Radiant energy device, energy from vacuum, free energy planet. Not the planet, though. They have to measure it to be a planet first, so that part we're going to take out.
Don't be a flat earther. Come on, this is free energy talk.
Don't be a flat earther. Damn, flat earth seeps into everything.
But Murray, man. Murray is a gangster, man. Is post in the live stream if you see a picture of his like apparatus on the street, with like 12 light bulbs.
Let's see. I probably there's a bunch of images in this article. Let me see. Hold on.
There's plenty.
I'll find some more.
Yeah.
I'll just go to images. Yeah, here we go. Like he was doing this public demonstrations.
30s, yep. Public demos.
Radiant energy. Let me take some images.
80-foot antenna, and off we go, bud. It's like, really? Like, so, you know what I mean? Like, yep. Not just that. You want a modern dude? How about this? I forgot his name. The inventor of the floppy disk. Okay? All right. I'm selling him out, but his house is very interesting. The exterior house is it's not a photovoltaic cell, but it produces electricity. Okay, all right. So and he should be still alive. I think he's the inventor of the floppy disk. Just chase that down, and you'll find that rabbit hole. Like I know the free energy rabbit holes like quite well. Studying those. So that's a good one.
Here's a plan review for the Moray generator. That's a YouTube video. Scarmorno.com, whatever that is. Find some weird stuff.
Let's see if I could find something
like this. Moray generator plans. Here's the actual plans. EnergyLiberationArmy.com. This is the storm which the energy companies were afraid of. A horde of lawyers is attacking this as we speak. Here, let me put this. Interesting.
Here, bro. Here. I found the image that I wanted. So here he's got on inductive load. Like he's got plenty of inductive. Oh no. Okay, copy image doesn't work on my phone. Okay, so I have to do it this way, the dumb way. Here, boom. Ta-da! He's got a heater. He's got. I think these bulbs were like 250 a piece, 250 watts.
You didn't see that I had just posted the same exact image. What the
Did you really? Where, man?
Just a couple minutes before. Bro, what's going on?
Oh my God, no, on my phone. Yeah, man, you did.
I mean, how was that possible? Because I was looking at a bunch of different photos. I mean, we picked.
I just Googled it right now.
Yeah, but why did we pick the same one, bro?
Because here's another one. the ether, bro. Come on, man. You already know. There's plenty of him, man. Plenty
So,
of them.
Sonny, you said you're not familiar with any of this. What you should read is Tesla. He gave a couple like lectures in front of, I think it's called the what is it called? The Benjamin Franklin Society or the Edison Society, like in
Okay.
England or something. So there's two of these, and both of them, like, they'll like lay. He's very like I think Tesla's underestimated about how well that's exactly what he's doing, because he uses a lot of analogies. So he often uses the analogy of plumbing. It really blows my mind that people don't understand like what he was doing. He spells it all out, like it's like in plain English, black and white. I don't understand. Like it's like and it's like the more education they have in mainstream physics, the less they understand, which blows my mind.
Yeah.
Yeah, the more blockage you have to understand.
Yeah,
the more, you know what I mean?
exactly.
Yeah.
That kind of goes to like what you were saying. Like, how did these people all invent like all this stuff? They had less preconceived notions. They didn't have biases. It blocked their thinking.
Another part that people miss on that is they had access to tools and things like that. Shop space, like that was ubiquitous everywhere. There were little shops everywhere around any little town or village. Probably several people had shops that were working with electrical stuff because it was brand new. People were fooling around, making radios, like all kinds of things. So there was access to shops and shop.
He had Westinghouse generators, this motherfucker. 3 of them, I think. It's like alternators. I'm sorry. It's like, holy smokes. Like, dude, you can run cities on this. And he's like, yeah, he's got 3 of them chilling in his lab.
In manufacturing,
Oh, my God.
like tools to do manufacturing with. Machine tools were more available, you know?
I also think that there's variables that have never been conceived of before. For instance, I think like the actual geometry. So say you have like some circuit design and you wanted to do something. People look at it as strictly in terms of voltage, current, amperage, resistance, those factors.
Right.
But I think that those things aren't affected by purely the material. I think that the actual geometric design of the circuit, like where is the inductor in relation to the capacitor? How far is it away in relation to
that kind of design.
Right.
Exactly. The actual geometric layout of where everything is. I think because when I'm going to go back to it, the thing called negative index of refraction, we know that if we design things that has a certain geometry relative to the wavelength, that we will get the electromagnetic radiation to refract in the so-called opposite direction. And it's purely geometry. It has nothing to do with anything else. It's just the geometry, the size of the elements compared to the wavelength. That's it. So you can do this in 2 ways, right? So there's one way you can do it. You can take a PCB board, right? And on the PCB board, you can lay, you can make like little capacitors. So like the letter C, right? If you have that in copper, right? That gap, that's the C, right? That is a capacitive gap. So if you send electromagnetic radiation for it, you'll get a little buildup of voltage in this gap. So if you make a whole bunch of these, that's 1/16 of whatever wavelength you're using, this capacitive gap will cause negative index of refraction. So here's the funny thing is, instead of using metal on insulator, you can just take an insulator and have cutout. So instead of it being something embedded in it, you can have a hollowed out part in the shape of a C, and it'll do not the exact same thing. It'll do nearly the same thing, but it'll do it at a different frequency with less loss. So like this negative refraction is frequency specific. So you like, if you vary the size of this capacitive gap or you vary the size of the geometry, you get different effects. And it's purely the changing of the geometry of the elements, nothing else. It has nothing to do with like current, voltage, anything like that. It's just the the relative physical location of the elements. That's it. And I think this variable is just completely neglected, because Tesla actually talked about this. Whenever he's talking about tuning or something, right? Yeah.
Fourth harmonic.
I'm tuning a circuit. How is he tuning a circuit? He's shortening He's shortening or changing the size of one of the elements in the circuit. That's how he's
physical geometry.
The physical geometry. Because think
a musical instrument. Talked about them.
Exactly. You can shorten the wire and get a different harmonic.
Exactly. That's what Dollard was saying. It's so hard to build the true Tesla tertiary coil, right? The one that plugs into, you know what I mean? Like, so you can transmit to the Earth by plugging into counter space or another dimension or whatever you want to call it. That tertiary coil, like the one he built back in the days, he said that was magical because you have to get the physical geometry right, you know. So so if you can build it like a piano, where you can tune, because it's a flat square coil, right? And so the gaps, the more like if you can achieve mechanical perfection in the geometry, that gets you even closer to whatever your desired goal is. Yeah. Yeah, it's good that you bring that up, man.
You're aware of like harmonics on a guitar, right? You play the guitar.
Yeah. No.
So where
I'm aware of the electrical realm.
Yeah, so how you shorten the string determines what the harmonic is, right? But you could think of that harmonic as something like, so say it was a current carrying wire, you could put something that on that wire that changes the way, like if you're using pulse DC or AC, right? You can change the way the waves propagate down the wire. You can do like a parametric up conversion or down conversion by putting something that basically is parasitic, not parasitic in the way of like resistance, but it just changes the way it propagates down the wire. Now, say I had a wire that's carrying a current, and like along that wire, I put like a piece of metal. That piece of metal is or an inductor, right? So say I took like a coil of wire and put it, parallel to the wire, that current flowing down the wire, that inductor is going to change the way that current flows. And where I put it along that wire is going to change exactly how that happens.
Right. Where in space
this is like almost an infinite variability. And I think this might be one of the reasons that this field is so hard to decipher, because somebody gets an effect and they're saying, well, you just do this with this current and this with this voltage and this, you have a resistor of this.
Yeah.
And they completely neglect that the geometry that they use as a factor. So someone goes to replicate it and they don't get the exact effect. They get something like it, but it's off a little bit. And then it's hard, it makes it almost impossible to engineer something useful because you're using the wrong variables to engineer it.
Yep.
So that's why you got to sit there and do trial and effect. Trial and error, I mean.
Well, I don't know if you read about Stanley Myers, the HHO, the water disassociation guy. He drove his buggy.
Yeah, I'm aware of Stanley. I think that's something to do with resonance. Some resonant tunneling effect. That's what I think is.
The problem, the fucker is lying in his patents. So that's another. He says it's a resonant circuit, but he's got a diode in his circuit. It's like resonant what with a diode? Nothing. You got, it's a choke. And he calls it a choking diode. It's like, yeah, dude. It's like you have no resonance like that. So it's like interesting. So a lot of people say it's on the pulse DC side of the world, but the best theory was like it's the mechanical. Again, he built it like a musical instrument where you can tune the position of the tubes relative to each other. Like the geometric spacing is like, like the first order of things. You know what I mean? Like it has to be mechanically perfect.
Yeah. Also probably the purity of the elements too, right? So if you use like impure copper wire, or say like magnetic coated copper wire, or like silver wire, like those will all affect it on top of it. So you would have to alter the geometry depending on the conductor use. So and the insulators, right? So the insulators also have electrical properties.
Not the magnetic, electrical world. It's fucking complex, man.
It's uber complex. It's like beyond complexity. You're probably just better off like doing some freaking machine learning on this shit and let the machine figure it out. Who cares if it's a black box?
As long as it works and sucks energy from the ether, and I got my internet off grid, I'm cool. I'm happy. Yeah,
you know, I
man.
was thinking yesterday. I was looking at some machine learning stuff, and like it's great for vision. I should like code up a neural network, like, and feed it like a bunch of images, and have it tell me what it thinks the shape of the Earth.
It's flat, you idiot. You know, like
The thing's gonna see. Yeah, that's what it says. It's flat. Is that another machine learning program coded slightly differently? We'll say refraction.
Yeah, that's what the Globey made it, right? Or Zanuck programmed it or some shit. Yeah. I think you can, but that sort of thing.
Zanuck is the AI.
We'll just call him Zanuck, right? Hey, Zanuck. Oh, yes, sire. No. Like Jarvis or whatever. Iron Man.
What are you doing, Dave? Hal 9000. Zanuck 9000.
Reference frame. Reference frame. The Coriolis era. I remember that shit. Coriolis.
It astounds me, like the Globers that come in here, and they'll come in and they'll say, how do you explain X, Y, and Z, right? And the thing is, X, Y, and Z doesn't exist. They just think it does. Like, they'll be like, how do you explain a plane flight from here to there, right? And they think that plane just like flies right from there to there, right? They have no idea that planes actually go to like a flight corridor and then fly to the destination in the corridor and then leave the corridor at some place and then fly to wherever. You know what I mean? They think they're going point to point. So I don't understand like why they believe these things. They literally don't research anything, and then they come in here and demand that we explain their freaking delusion, right? Explain my delusion.
Too much TV, man. I think that's the best conclusion. For me, though, I haven't watched it since I was a teenager.
Explain my ignorance and factual error. Okay.
Oh, you don't read.
Lazy.
You don't
How
read,
about
sir.
that? That's my explanation. You're lazy.
Yeah.
You couldn't take
Educate
the 3
yourself.
seconds it would take to Google it.
Right.
I mean, they don't think about it for a second. Okay, say I'm flying. I'm a pilot. I'm actually going to take off and fly to somewhere. Well, different airports have different taxi times. You take off different ways. You don't land the same way. Sometimes you're taking off into a headwind. Sometimes you go in a direction, you're flying against a gesture. There's so many factors that affect flight times, right? A total flight time, right? How fast are you climbing, right? So you have to climb faster in some places than other places, right? If I'm taking off from freaking Tibet, I'm already at like 8,000 feet. Right? And plus they have a really fucked up runway, like the hardest runway to land in the world. So you have to come in at the exact right angle. Probably got to circle like 50 times before you even land. Right? So how do you count for that time? Like, it's just silly that they have these like almost childish notions about how like an airplane flies from point A to point B. RC Micey, I'm a pilot. How do I calculated my fuel and reach this freaking area? Like, dude, do you like fly with just enough fuel? Like, what are you like? Oh, I calculated it, and if the Earth's not a globe, I'd fall out of the sky because I only bring just enough fuel to get there.
Durr.
It's just silly stuff, man. Like, it drives me crazy.
Yeah, they're using aircraft as a measuring device.
Yeah, RC Micey said, well, I flew from here to there and I calculated the fuel. Why didn't I run out of fuel? Because you don't bring exactly enough fuel, you moron. Because you fill the tank.
You fill up, man. You fill up, dog. Just in case you fill up.
I had someone on here disagree with me. I said
I don't miss RC Micey, bro. I don't miss him at all.
I said aircraft of any type are not measuring device. I had someone disagreeing with me over and over, disagreeing. Yeah, it is. Yeah, aircraft is a measuring device. No, it isn't. How so? Yeah, it just is.
An aircraft is a measuring device?
Instrument.
Yeah, that's what they think. They think it's a measuring instrument.
Damn. What does it measure?
They think it's measuring their ball, obviously. They come in here and say aircraft, Earth is a glob.
It's a ball measuring device.
Nice. Wow, that's pretty cool.
Yeah.
What's the patent number on that apparatus?
Really.
Let me see. Let me read it. I'll read the patent myself.
See things
The ball
flying,
measuring device.
you see things flying around in the sky, therefore Earth is a glob.
You know, here I was asking. There was someone in debate text today. I was like, he's talking about space. Like they go into a spiral as soon as you tell them space doesn't exist. So I'm like, okay, dude, settle down. Was space discovered or invented? And he was like, discovered. I'm like, okay, who discovered it? Somebody. I don't need to know that. I'm like, we know who discovered America, right? Christopher Columbus, but we don't know who discovered the universe. So that makes a lot of sense, right? No, dude, it was invented in the minds of a man. And we know who invented it.
Who did?
They never asked Epicurus. Epicurus is the first person that came up with outer space. He also invented atoms, so that should tell you something.
Oh, okay.
He invented that's kind of the foundation of all of modern physics is the Epicurean idea of matter and void.
Yeah. Instead of
there's either matter or there's an
dude,
infinite void.
Pretty old. Yeah. Right.
And he was dude. What a good guesser, right? He guessed the entire universe in 325 BC.
Yeah.
All of physics, dude. He guessed it with no information. Before the number zero was even invented, he guessed it.
Prophet Epicurus, yeah. All hail Epicurus, yeah, is that it?
No shit, dude. All hail Epicurus, the progenitor of the entire universe.
And that's
that's peace be upon him. That's Epicurus, peace be upon him.
That's right. and that's not archaic.
That's crazy, man. Wow. Yeah, they stand on weak ground.
Well, how many of these concepts, these globe concepts, were discovered versus invented? I mean, like nearly all of them. They said, Earth's a globe, what are the consequences? Blah, blah, blah. It wasn't like they were doing something and they were like, holy shit, I keep missing with this bullet, man. Why is that? And then they researched it and they're like, wow, this correlates with the rotation of the Earth. It didn't happen like that. Like it was like, man, if the Earth was a ball and we were spinning, we should see this. Let's run around and look for that.
Yeah, when have we ever seen a ball or a sphere in nature?
There you go. There's another one.
Sphere in nature. Oh, let me get you. I'll get you one. Pearls. I got you.
A Zulu sphere.
Man, that's some cherry picking. You need a lot of pearls to get a perfect sphere, man. You're combing through tons of pearls.
You are 100% true. You're right. Most of them are sphere. You're right. You're right. They're cool. They come in all colors. Pearls are fucking badass.
We have the Congo sphere. We have the Native American sphere. We have the
every here and there you'll get a ball. Let me see. What else? What else? Oh man, all the crystalline structure. I'm thinking of crystals, right? That's why it's like I'm going crystals. Like I'm gonna prove you guys wrong. Let me find a sphere in nature. What has spherical crystalline formation? Nothing of that I fucking know of. You know, they're all, you know, cubic, rhombic, you know, that sort of, you know, like.
Hey, just remember, this conversation is an example of science denial. We're science deniers.
Oh, sure. We talk about crystalline structures. What are you talking?
Us pointing out that they're using ancient Greek metaphysics as some form of superstition and doing a 2,000 years of confirmation bias is science denial.
Yeah, we're denying
that's for sure, because you're denying the existence or the truth of their messenger, Epicurus. So, or their prophet. You know, he saw the future. So, yeah, how dare you?
The thing is, this isn't like people might say, well, nobody pays attention to that. I can show people many presentations given by physicists now, you know, talks or lectures, the Royal Society lectures. They still talk about this guy. Okay. They're still talking about him. It isn't old shit. They're still talking about him. You go to any lecture on atoms, quantum physics, or any of that, they'll usually start with the history. And when they start with the history, they talk about Epicurus and how he came up with the idea of atoms. Something that's indivisible. But guess what? That he was wrong about that. We know now, right?
Yeah, we can divide. Well, I guess that's not an atom then. That thing we divided, yeah, or we can, yeah.
Well,
Is that
aren't
an atom?
atoms divisible? Aren't they made of electrons, protons, and neutrons? Aren't those made of quarks, leptons, gluons,
Yeah.
and a bunch of other stupid
Yeah.
shit?
And then guarantee you, those when you keep on cracking, you'll find they're made out of other stuff too. Until our
But then when
technology,
you get below that, it's not even material, right? It's a quantum field. Like it's not even elements anymore. It's not even discrete chunks. It's a field of shit. So at the bottom of everything is just a field.
Yeah. Nice. Mind boggle. This is my kind of morning talk. I like this.
Like, there's no difference talking about this or talking about like some fantasy series that about Middle Earth or something. Like, there's no difference. You might as well they could just ship this. If someone took all this gibberish and put it in the fiction section at the bookstore, nobody would even notice.
Mm-hmm. Put Einstein's work in there. No different. Novels.
Well, Star Wars is based on that.
Fairy tales and unproven pseudoscience.
You ever smoked dilithium crystals?
No, I bet that's some good shit.
Warp 10, brother. Warp 10.
Warp 10.
Go back in time and save the whales.
I think somebody's snorting some globe crystals.
So, Sirius, what do you think about quantum tunneling?
I haven't read enough about it to really grasp any quantum anything, really.
Well, it's actually it's observed macroscopically too.
Okay, explain to me the effect.
Well, according to them, this is them, right? So,
okay.
I'm trying to think about how to describe this without being fucking I try to decipher their gibberish into English. Hold on, let me get my translation machine going. So everything is according to them, right? So because of the fact that, well, I'll give you the quantum version first. So because quantum particles cannot be localized, right? And where their location is actually a probability amplitude, the wave function, right? Spread across space. Could be anywhere in this space. Part of that wave function overlaps the barrier, right? So say you have, one material and then a barrier of some material, and then, another material on the other side.
Yeah.
Some of that wave function, when it comes to the boundary, overlaps, and there's a non-zero probability of it being on the other side. So sometimes it spontaneously jumps through the barrier to the other side.
Okay, that's when the material is obviously thin enough, extremely thin and whatnot, yeah?
So this is the explanation, but this is another one of these things. In this case, quantum tunneling was not invented; it was discovered, and it's been discovered. And the explanation is ex post facto. So there's something called a PN junction, right? So you have something that's a material that has an excess of electrons, and a material that has less electrons than it could possibly hold. So if you sandwich this, we put a semiconductor in between them, it will jump this. This will jump this gap, right? And what they say is there's electrons and electron holes in one material. So the P has excess electrons, the N has too little electrons. Sometimes, if you apply a voltage across it, right, this bias will give a little extra boost, and some of the electrons will jump into the N material. And then there's a flash of light, and this is how we make LEDs and light-emitting diodes. This is what a light-emitting diode is. It's a PN junction.
Yeah, okay.
So they work by so-called quantum tunneling. So there's actually a bunch of different models for this. I actually seen one model where it was actually modeled as just like a regular current, just as a regular electric current. And that the semiconductor has what do they call it? Band gaps. So there's I don't know if you ever heard the band gap model, that at certain energy levels, it's as if this material is transparent and the electrons can just travel through it. Right, it's a semiconductor, right? So in specific voltage ranges, it will carry a current. So this is one of the ideas. Here's the problem. Not actually a problem. It's been observed macroscopically. So the Navy, they were doing sonar tests, right? So they're shooting out sonar. And there's supposed to be a mountain under the ocean. And they're picking up something that was like very far away. What they found out was their sonar waves actually tunneled through the mountain. So this is an actual. So it has nothing to do with the wave function. It has nothing to do with the probability amplitude or anything like that. It's just a property. My personal opinion, I think it's a property of just matter generally.
Material.
That if you have let's call it a material, right? And this material is homogeneous. It has to be kind of like one thing. Could be whatever. It could be wood. It could be
pure.
Freaking stone. Pure. So just one thing. It's just one thing. And if you have like a medium on one side and a medium on the other, somehow that things can just like jump this material as if it's not there. And this kind of goes to this like thing, right? That for some reason, I think materials that are the same thing like to be together. And they'll actually repel things from being inside of it. So if I shoot something at a material, it might be energetically more favorable for it to just teleport to the other side than it is to be inside it. And the material just repels it because it just wants to be together. This is my pet hypothesis, I guess you'd call it.
Nice.
Which makes a lot more sense to me than mass attracts mass or fucking, spooky action at a distance or teleportation or freaking quantum, probability amplitudes and virtual causal quantum erasers and silly shit, dude.
I'm not into spooky action. I'm not Newtonian. I'm very J.J. Thomson when it comes to that. Action of this, there's the tubes of force connect everything.
Doesn't have to come up with stupid, like literal contradictions, like superpositions, that things can be in the same place at once. And this is just accepted as if there isn't a problem. Listen, 200 years ago, if you said my theory involves things being in two places at once, they would call you a fucking crank. They'd be like, something's wrong with you.
Yeah, they would.
But their mathematics, right, shows that.
Wait, are you trying to tell me that I'm not in two places at once right now?
How much weed you got?
Apparently not enough.
What's the strain, bro?
You got the mainline weed to fucking get that fucker.
I'm just kidding. But seriously, there's like 4 of me on Earth, so you'll never know who you're talking to.
Sure.
So this is their thing, man. Like, look, it's almost like in this quantum tunneling, you have a particle, a particle that has no specific location. That's some smeared wave function, an electron cloud, right? And it's on both sides of the barrier at the same time. It's in both places at the same time in the mathematics. So to them, this is plausible. Then they come here and say, the Earth's a globe. It has to be a globe because science. Like, well, why don't I just say it's flat and a globe at the same time? Because you guys think that freaking things can be in the two places at once. Why can't it be a globe and flat at the same time? I mean,
That's
if you're we're gonna,
that's a good one. Start applying superposition on their ass.
yeah, we're in a superposition of geometries. Because this is what children think when they're told it's a globe. They're told they actually come up with a two Earth concept that they think it's flat on the ground, but if you go far away, it becomes a ball. So, like, let's just go with this. Let's think like children, and we'll go through reality like that. How about no? How about no instead? But it's just the silliness that is completely accepted, right? That the mathematics says whatever, that you can be in two places at the same time. But I find it more interesting that this has been observed macroscopically. And what's interesting is it's superluminal, that the dwell time in this barrier is 0.
How dare you use that word, superluminal? Sir, the speed light is the limit. The speed of light. No, wait, yeah, the speed of light is the limit.
Blasphemer! Burn him!
So wait, is there light past the firmament? And if so, how do we know how fast it's going?
Firmament?
I'm just kidding.
I know. It's fucking brilliant, but it's all good.
Does light move faster inside the snow globe or outside?
So here's the funny thing. Here's the funniest thing, right? Now, they say that the distance, right, the barrier can be some length, right? And that length falls off exponentially by the wavelength of the light, whatever. So the funny thing is, here's the funny thing. The formula is identical to what the distance is for near field radiation. So that's non-transverse radiation, right? Near field coupling. So if you get too close to something, you'll electromagnetically couple to it.
Yeah,
like a big antenna.
Yeah.
So this barrier distance is the same way.
Well, you
it's
don't
the
get
same
too close
distance.
to high power antennas.
So with this quantum tunneling, this is a DC. This is a non, because you in a diode in a LED diode, it's a DC bias, right? So it's not alternating current. It's a DC bias where you're just creating kind of like a little tug on it. And in diode, I don't know how much you know about LEDs, but they only work in a very narrow
way.
But they only work like in a very narrow voltage, right? So you got 5-volt diodes. They only work pretty much like from 4.99 volts to like 5.01 volts. There's a very narrow voltage.
Yeah.
And if you're outside of that range, they just don't work.
Right. You smoke them up pretty easy too.
Yeah, exactly. And if you don't put enough, they just don't work. It's not like they're not bright. They just don't work at all.
Are those, I think they're called Zener diodes? I'm not sure. They're like tiny ass vacuum tubes. They're like little glass bulbs.
Oh, yeah. Zener diodes.
Zeners, right? Those are pretty cool.
Well, the point I'm getting at, this is another thing where like the geometry, how far away these are, is directly relate. Like, do I want quantum tunneling? Well, I gotta take your geometry into account, and then I gotta correlate that geometry, that distance, to the amount of energy, right? So different energies mean I have to use a different distance, right? Different wavelengths means I have to use a different distance. Like there's an intrinsic geometry built into how electromagnetism works.
100%, because it's archetypal of space, right? Magnetism, 100%, and electricity. You know. Like the antennas, it's the physical length of the antenna will determine, like, what wavelength, what band it picks up.
Exactly.
Yeah,
exactly.
You can make it into a snake. Yeah. Like it doesn't matter. Like as long as the length of the wire is the same, you can like compact it in different configurations. It will have different properties, right? If it's flat and like circular, it'll have low capacitance. You know what I mean? If it's like a coil, it'll have higher capacitance. It's like shit like that. You know, it's like a coil, like a 3D coil. You know, not a flat coil.
Well, and then you have the impedance, right? So I have a wire hooked up to the antenna, right? So the impedance mismatch of the wire versus the antenna. When you think about what is the actual difference between, say, copper and aluminum, right? It's actually the geometry of the atomic particles in that material.
The molecular structure of the crystal and fucking stuff. Yep.
Exactly. So it all comes down to geometry. It has nothing to do with anything else.
Music.
I mean,
that's why I always felt the musical world, like I'm not music, like it's just musical. Like Tesla and those guys built their apparatuses like a musical machine. You have to tune it. It has to be perfect, right on. Like, you know what I mean?
Yeah,
we do that today.
We hit that frequency when that big lady be singing, you know, next to a bunch of them wine glasses. You know, that big lady be singing, and wine glasses go, she got to hit that frequency dead on.
And that's exactly what I'm talking about. Electromagnetic coupling is the exact same thing as that, right? So if a woman sings at, say, a C, and the glass's natural resonant frequency is also C, if she sings loud enough, she can bust that glass through destructive interference.
Right. Yep. Sympathetic vibrations, yeah?
Yes,
right.
Yeah, exactly. And this happens in anything that exhibits waveforms exhibits this property. The things that will can resonate at that frequency will resonate at that frequency if they are close enough to that the emitter, whatever is emitting it.
And to us, it causes destruction, but it shows the power of the frequencies lining up, right? To us, it breaks the glass. To reality, it's just doing what it's doing. But for us, it's violent. It can get really violent.
The glass breaks because of like the deflection in it, right? Because it can't hold tension. You know what I mean? Because it's starting to wobble though. Because now.
Yeah, the glass can't hold the tension of the vibration itself. The glass is really weak compared. The vibration is like infinitely strong.
Yeah, well, because in a right band, that narrow ass band, that now once you hit it, now it can absorb power. Now it can transmit energy way easier. Now you have very efficient energy transfer in the glass busts.
So if it were like bulletproof glass, it may take longer to bust, or it'd have to be a different frequency anyway. But you know what I mean.
Plastic, I don't think it'll have the same effect. However,
and the thing about glass, it can't dissipate the energy. That's the thing. It's intaking more energy.
That's what I'm trying to say. Yeah. Would the plastic actually absorb the energy? But I mean, you could eventually break the. So it would just melt the plastic.
Well, and if you look at the molecular structure of glass, it makes sense why it can't dissipate the energy because of the way the molecules are shaped.
Yes. Again,
it's not held together in a regular crystalline form. It's called an amorphous crystal.
Don't tell me the crystals are fucking triangular shaped, bro. Don't tell me that shit.
Oh, bro, I like metallurgy, so the crystalline structure and like the phase diagrams. Oh, dude, they're critical. So it's all about the geometry. Like it's essential, and we did forget about that in the electrical realm and shit like that. You know, the alloy, the metal, like everything matters, man. Everything matters. So cool.
Yeah, everything's got a frequency, and so that's how people get afraid. Deep down, people know that it's possible for radio frequencies to travel through your body and disturb shit, mess shit up. Everybody's like, no, hey man, the 5G thing, that's just, it's just distraction. Well, what if it's not? Just real quick. Like, I've never seen so many towers of anything put up before. For the 4G, they didn't need many towers. For this, it's like, oh my God, it's everywhere. How's that not going to affect you?
We can map out your emotion in 3D space, you know.
Yeah.
Do that many, I really think that's what they're trying. So, I mean, hey, if your device is capable of doing this, why not? I mean, just as a scientist, like, why the fuck not? Let's see if we can actually make this work. Hell yeah.
True.
Map everyone out in 3D is like, yep, right through the walls.
Oh yeah.
So fun story. I was walking in the city, like I think it was a year ago, and there was a skyscraper being built, and the only thing that was completely finished was the tower that they put on top. That was the only thing that was finished. The rest was all in scaffolding, and the only thing that was working was the tower on top. It was
Well, we need 5G to finish building the building. I mean, it's how every building is built from now on. Top down, 5G first.
How else are they going to control the workers, man?
Mm-hmm.
Sure.
They're controlled by a beacon. They pick up the signal and they just start hammering and nailing stuff.
Seriously.
You just send out the frequency, they all start fucking hammering.
That's right. Keep the drones going. Hey, it's not too far from the truth. That's the scary part. I got my 5G phone. I have to pay for it. Let me go to work and hammer a nail.
Hey, wait a minute. What's wrong with Steve over there? Oh yeah, it looks like he's trying to screw in a nail. We better change his frequency.
Yep. Yeah. Exactly.
Why not? I mean, look, man. If I had access to the switchboards, listen, I'm just gonna play. I'll be honest, and I hope that's not what they're doing. But I'm sure there's some nerds out there that want to test
talking
out.
About energy and frequency. I heard they are using that shit now in Australia and Canada. LRADs.
Was that the sound device, the LRAD?
Yeah.
I forgot. Yeah.
Mm-hmm.
The thing about 5G is that it's multipath and highly reflective. So it's not like you're like swimming in it. Like you're taking a bath in it. It's like coming at you from every possible direction because it's reflecting off of every surface. So there'll be little focal points and little nodes where it's concentrated. And maybe that's where your desk is at your office, right? So you're just sitting there at your desk, just getting pummeled by electromagnetic radiation.
That's messed up. Because I hear
Faraday cage. I'm gonna buy a Faraday cage next round. Just drape copper mesh.
Faraday suit, bro. Let's get the Faraday suit. No, here we go with the tinfoil, right?
Yeah, it is. It is fucking tinfoil. I know. It is whatever, man. It works. It works, bro.
I'm gonna cover the whole inside of my apartment with tinfoil.
Dude, I'm experimenting with like different materials. I don't know.
What do you think the Globers try to stick an antenna on their head? That's the fucked up part. You want more?
Collect that shit, right?
Plump it right in.
It's free.
Just wire it right into my spine.
Yeah, we'll just place the antenna inside of you internally.
Well, you couple, right? Like at least, so, all right, the glass, back to the glass thing. That's one harmonic that you can do this on, right? That's not the only harmonic you can do this on. Because like, let's say whenever you play a note on a piano, like the harmonics, the other strings are on an even division of that, they're also vibrating, but at a lower amplitude. And they all add up together to create the sound that you hear. It's not pure. You know, so whenever you like the glass, like it's picking up, it's not a pure tone at all. It's picking up many harmonics. It's like, and it's called additive and subtractive synthesis. So it creates the waveform. When you zoom in, it's not so smooth. It's many waves added to each other in this envelope that gives you this, right? So Tesla supposedly, right? He tuned his coils to the fourth harmonic, which means like, let's say if it's a coil, whatever, 100 hertz or whatever, just arbitrary numbers. He tuned it to like the 400 hertz harmonic, right? Depends on whichever divisions he was working off of. But like the second harmonic would be 200 hertz, third 300, and so on. You know. So I don't know what harmonic, but he said to the fourth harmonic he was tuning like. It's like, wow, okay, huh? Like the length. So the length of the antenna, right? Let's say I want to pick up a microwave band. That's what, 2.4 centimeters, something like that. Quarter wavelength antenna. boom, I know how big that is, right? Or 10 centimeters, I'm sorry, 10 centimeter band, I think, is microwave. So you just measure that out, but that's like the first harmonic. And somehow he can tune that to like 3 more levels in. It's like, whoa, fine tune it. It's like he built musical instruments, pretty much. Electrical musical instruments for radio propagation, or wireless propagation, I should say, of electricity. Which is interesting. I don't know how to do that. He had no oscilloscopes either. Had light bulbs.
So I should eventually be able to get into my vehicle, plug in my guitar, and start strumming it and power the car.
No.
I don't see why not. Why not?
No, you would need one of would it be Brenda's space-time donuts?
No thanks.
You know what I mean? To change the guitar tone into a usable fuel for a vehicle.
Okay. I have a real donut shop down the street if I need one.
Got it. Yeah. Yep. So does the diabetes inside of that space-time, is it different than the space-time outside the donut? Or yeah, well, anyway, I miss Brenda.
You would have to ask Brenda.
Yeah, I miss Brendan.
Oh, hey, Indio, are you still there? Have you
you
ever
guys talk
looked
about
at
important stuff. That was not important.
Yes, I'm here.
the Tesla, the hairpin circuit? Hairpin. Sorry, I'm eating.
Yeah, someone actually made a replication of that on YouTube. Have you ever seen it?
Yeah, see that guy, bro, lighting up light bulbs with a thin ass wire across the room. Yeah, I seen he was like lecture/demo sort of thing. Like, wow, some old video I watched. Wow, it was old 10 years ago.
Yeah, exactly.
Yeah, that's something very cool for the Tesla fans out there. Hairpin circuit. It's an interesting apparatus. Yeah, I remember. I remember a guy with a bulb sliding it up and down like these copper conductors too, and doing all the demos like Tesla said. Right? It's like, yeah, okay, interesting.
In one of his lectures, he talks about some sort of communication device
placed in the pocket.
Really weird, man. It was like it looked like a bulb, something like that.
Or no, that's a prediction.
He didn't really go into it much, but he had a diagram of it. The diagram in the lecture, it's like the shape of almost like a vacuum tube, but in the bottom is like chips of nickel shavings or something. Really freaking weird, dude. I'll find a picture of it. It's bizarre. Like, he doesn't describe it, but he said you'd be able to talk to people like around the world, and no one would be able to eavesdrop on it. But I have to find it. I'll find it. Give me a second. Or a minute or two, actually. Tesla stuff's hard to find now that dumbass car company exists.
I think that's why they did it, man. I think that's why they named it. So it kind of drowns out the real Tesla, because a lot of people were picking them up. This is, I think, like 15 years ago. My dad is the one that taught me about Tesla. He didn't know shit about him. He's like, Edison is the thief, but Tesla is like the real inventor of electricity. That's cool. So then I started my Tesla journey. So it's like, so. Anyways, people were picking him up with the flat Earth thing quite a bit.
Real quick, you guys need to check out and save to your devices the latest Ladies' Night advertisement by the lovely KJ. She did a second one here, and I just posted it in the voice text. Spread it round.
All right. Right here. Okay. Get some shit done.
It's funny. It's like I don't speak on Ladies' Night, but I plan my Fridays around being here for it, so I can hear it.
Yeah. I need to change my schedule so I can be back in time to listen to it.
Virgo Greg, can you hop on voice? Because I'm trying to do shit, and I want to put my phone in my pocket and do stuff.
Is he DMing you?
Uh-huh.
Yeah.
About the Stanley Meyer thing. Because if you're listening, I'll show you my generator. I brute force, I just wanted a torch. I wanted the gas, high output. I didn't care. I wasn't going for a water device for an HHO device to put in my vehicle. I just wanted a hydrogen torch. So I built how many watts? My fucking thing. It can easily suck 160 amps at 12 volts. Easily.
I will assume that that's impressive.
It's just a lot of heat. If it's just, it's not very efficient. So most of that starts boiling the water, which you don't want that because you get water vapor then in your gas stream. So, of course, you can put a water trap and whatnot, but yeah, it's not efficient when you do that. So, however, I just wanted the gas. I didn't give a fuck.
Well, the water stream stays separate from the gas, right? No matter what it does. You can't merge them.
The vapor? No, the vapor will all flow up the tube with the gas from the because you're okay. So if you have a closed bottle and you put two metal plates and enough voltage, right? You get electrolysis, and on one plate you'll have hydrogen formation, and the other you have oxygen, and it's all that, and it'll never, unless you reverse the polarity, then yes, you'll reverse it. As long as your polarity is the same to each plate, so that rule is not going to be broken. So in that, if you want to isolate the gas, then you can put that plate, shroud it with a glass envelope that's open from the end and then goes up into one tube. That way, if you want to isolate the hydrogen from the oxygen, or you can let them combine and go up from your jar or whatever, your vessel, from the end through a single tube, and that will have the hydrogen and the oxygen combined which is quite explosive because it has the perfect amount of oxygen for combustion and needs nothing from the air. So it's extremely dangerous to store. And because the flame front of hydrogen, the wave front of that flame is so fucking fast, it just blasts. It just blasts shit.
Is it faster than the speed of light?
No, it's not.
Let's ask a Glober.
It's not superluminal.
Okay.
Hey guys, can I interrupt you real quick to ask a question?
Go ahead, bud.
I'm wondering, how do I get permission to upload documents into the chat?
You need link image perms.
Yeah.
And I cannot give those out. I don't think Cyrus can either.
Okay.
Why not? Why
oh no, you're a mod. He's a mod. He can do whatever the fuck he wants.
Yeah, I'm on my phone though, so I don't feel like doing it on my phone. Someone else can just click with a mouse. Any other mods are in.
Well, if anybody could do that for me, I'd really appreciate it, because there is some documents that I have that I'd like to share with people in chat once in a while that I find are pretty interesting.
You have the Flat Earther tag. You should already have that.
Yeah,
doesn't go with the Flat Earther tag anymore.
Oh,
because people were because someone snuck in and porn bombed the channel that had a Flat Earther tag. So, but I'll give you the permission. How long you been here? More than 3 minutes, right?
Well, I just jumped on just now, the last 5 minutes, but I've been around on
how
this
long have you been on the
server for
server?
a couple years. I'm sorry, what?
Okay. Yeah. Okay, that's fine.
Yeah, I've seen him around too.
Yeah, I was introduced to it by a guy named Robert Pisano, and then he got me in contact with Jose, and Jose verified me in.
All right. Cool.
So that's how I got on a couple years ago.
Bird name.
I already believe you. Yep, for me too, man. It worked. I was like, yep. He dropped the right names.
I don't think a lot of people have seen it. Cool. And I actually got this document from Robert. Was prepared by NASA, and the title of it is "Optimal Guidance Law Development for an Advanced Launch System." And it's a pretty interesting document. If you go to section 1, page 2, under using simplified models, it states in the very first sentence, Chandler and Smith have developed an IGM for the Saturn V vehicle. It is based on a flat Earth, no atmosphere model, and is further simplified with linear angle steering guidance. That's pretty interesting statement.
The Saturn
They're
V?
trolls. They're trolls, man. That's all. I don't believe anything.
You're
these
good on
fucking-
the perms. You're good on the pick perms now, but you said Saturn V?
Yeah.
Yeah, I believe. Yeah, so Saturn V.
That why they used a flat Earth model to fly to the moon?
I'm telling you, they're trolling us. They're trolling us, man.
Yeah, that's got to be.
No, I'm not trying to
Come
troll.
on.
I'm not trying to.
No,
I'm
not you.
troll.
The fucking document.
NASA.
Oh,
Yeah.
right.
Not you.
Yeah.
Yeah.
They're trolling the world, man.
Yeah,
Trolling the
dude.
entire
Everyone.
world.
And it says it multiple times without in the document that all these systems and I even have some other documents about how they develop missiles and guidance systems, and in them when they create them they're using flat Earth model, and they admit it in all the documents that it's not, they don't create them based off their sphere model that they give us, which I thought the debate was over. I thought they proved it was a sphere. So how come they can't use their own model to create their own guidance systems? They have to go off a flat Earth model?
Because their model was purported prematurely.
Yeah.
Sorry, go ahead.
No, I know the answer. It's just I like playing devil's advocate and putting it out there for people that are new to the server, that you could go and find these documents yourself online and look it up and read it, and and ask yourself, what are they saying? Why are they saying this?
Yeah, and there's that 35 documents link too. So so just in this conversation, 36 documents that we both know of. That why would they ever use flat Earth or non-rotating or level or stationary at all with the Earth if it were any of the opposite things, curving, moving, etc. Why would you ever once, let alone 35 plus times, have to fucking say, well, just in case it's flat, we're going to use it for flat for this experiment? No.
They're using flat because it's a refraction.
You're right. The globe refracts to a flat plane. Correct. Yes, you're right.
That is the only place. Yeah, that's the only place a curvature exists is within refraction fantasies.
Yeah, so after refraction, Earth is flat. Before it's a ball.
So how do you crash a rocket into a refracted horizon?
It just refracts around the ball, doesn't it? It just keeps on. No, it will skip across the water, like the skip and stone hypothesis from that one. It's gonna bounce.
It skips across.
Yeah. Like he
That's
said,
kind of funny analogy that you
that's
just
what the
brought up.
laser
I
was
remember
doing.
that recently SpaceX launched they did, where it looks like the rocket, when it reaches a certain point, it almost sort of implodes, and you see it almost looks like it's skipping across some sort of barrier. Are you guys familiar with what I'm talking about at all?
Yeah. So like if you skip a rock over a lake, from your perspective, it's bouncing on top of it. Well, this looks like it's upside down, right? It's bouncing. Yeah, on something upside down that way. Yeah.
Light
you.
skips across water. You didn't know that?
Light does?
No, man.
Ask a PhD in cosmology that teaches at the University of University of Britain.
Yeah, something like that. He's British dude, right?
I feel like I could just take your word for that.
It's on my channel. You can listen.
We have it. It's recorded, bro.
There's a reason why we record things.
Yeah, for sure.
It ain't just because we want to spy on people. It's because, we want to get these people on record. That they don't know what the hell they're talking about.
True cosmologist.
He literally said Epicore test happened and was successful because light skipped across water like a rock.
And I think the entire chat just lit up when he said that. Like, it's just like.
So did it?
I know he made us spiral.
Wait, did it skip up to the Sagitta and then skipped back down from the Sagitta?
Yeah, like a skipping stone, man.
You want to know the reason why they don't use spherical geometry for any of these things? Just look at how difficult it is to do rotations in computer graphics. Because you get things like gimbal lock, like in the mathematics itself, it's very difficult to do.
It's like this, man. If I were to go start training to be a pilot, and I would be telling them, okay, so but when do we account for Earth curvature or spin? And the whole time they're like, dude, we need you to stop asking that question. You're wasting our time.
Because when you're using a ball as the basis of everything, you have to do rotations to figure out anything. So, right, you need the orientation of the craft, you need the orientation of the Earth. So to figure this out, you have to do rotations. And rotations are mathematically notoriously hard. So they need to actually use multiple methods. They need to jump between linear algebra, matrix algebra, and quaternion algebra, just to be able to do anything depending on, the relative positions of like the craft to the Earth. This is like a known problem in computer graphics. That's why they don't do this shit in computer graphics. And that's why astronomy is a point, because they keep, listen, people, math is reality. Well, that math can't really model certain parts of reality, especially when you...
You know what math is? It's utterances from a being. That's what it is. Math doesn't exist.
It's a tool. Quoting Heaviside, he said you could come up with any mathematics you want, as long as you can trace your way backwards. You're good.
Hey man, can you explain mathematics to a cat?
That's like
what I'm trying to say.
One of the lead fucking mathematicians of all time. Like, that's Oliver Heaviside.
I know, but what I'm saying is math is just is like an opinion, and then communicated with utterances. But the opinion, it only exists in our head. I can't explain math to my motherfucking cat, but I can explain to him what food is and what's different about these foods.
With numbers, mathematics is a language. Like English and Spanish.
Oh, the language
is
is a contrivance. That's what I'm trying to say.
Right. Yeah.
It's a way to compactify concepts into symbols, right? And then use like those symbols and use like certain operations of those symbols instead of writing it all out in words, because you don't have to use symbols. You could write it all out in words, right? I could write out the number 1 in a word. I don't have to use the letters and all the symbols, right? And all those would have definitions, and I can use those. Like, man, you think mathematical equations are long now with just numbers and symbols. Write out the whole word, man. You're gonna be writing down shit forever. You're writing down shit. 20 pages of equations just became 2,000 pages.
Yeah.
Isn't mathematics also like coded in nature? Isn't there
Fibonacci sequence?
You're cherry picking. Listen, it's cherry picking. Just because certain types of mathematics can model aspects of reality, you know how many models failed?
Right.
Like, oh, let's use these mathematical. Oh, that doesn't work. Let's try this one. Oh, that doesn't work. And eventually, through trial and error, they came up with one that actually does work to a degree, right? It's never 100% precise. That's how you know a Glober's a propagandist when he says, predicts things perfectly. You know he's full of shit. Right. Mathematics doesn't predict anything perfectly.
Not only that, post-dictions.
Yeah, exactly. Data fitting, right? So you can take a bunch of data and do what's called a least squares regression and figure out what the average is of all those data points. But you know what they say? There's no such thing as the average man. He doesn't exist.
Right? So even are you saying that even to like if you try to use mathematics to prove creation, that you're still in a way kind of cherry picking because you're just throwing multiple equations at something until you get the answer that you want, so it doesn't necessarily prove creation. Like DNA, human DNA, for example.
Yeah,
isn't it?
But rules prove deliberation.
Like intelligent design and code inside human DNA. So if that alone, doesn't that prove intelligent design?
Let me say this real quick. So patterns are deliberate, right? Patterns don't happen naturally like they think it does with evolution and stuff. So since rules and patterns are put in place, something had to put them in place. That's my opinion.
Yeah.
Now, let me give you something a lot of people don't know. Something called the problem of measuring a coastline, right? So if I want to measure, and this applies not just to a coastline, any surface or boundary that is undulating, right, that changes direction. So a rough surface, a coastline, it could be anything, right? The surface of the Earth, right? So it's got mountains, valleys, all that stuff, right? That's an undulating surface. It's not smooth. It goes up and down. So if I wanted to measure the distance between point A and point B on this surface or a coastline, the length will change depending on the unit of measure that I use. And the smaller of unit of measure you use, the longer that surface becomes. So like if you try to measure like the coastline of England and you keep like, I'm going to use miles as a unit. Oh, I'm going to go down to half miles. I'm going to go down to meters. I'm going to go down to inches, millimeters, nanometers. Oh. The coastline will get longer and longer and longer and longer the further you go down in units. And it'll get shorter and shorter and shorter the more you go up in units. So something as simple as measuring the length of something, right? Because there's nothing actually smooth in nature. You can't even measure the length of something actually.
Mm-hmm.
We can pretend we do. So it's this long if I use inches, right? But if I use nanometers, it's actually longer than that.
And it grows and shrinks too with temperature, man. It expands and contracts.
Oh yeah, then you got all those. Yeah, then there's just the variability of nature itself.
You gotta fix the temperature to have length. You know what I mean? Otherwise, you're all over. Like, okay, accurate.
Wasn't there some recent study done by a university too that they actually measured one of the states? I don't know if it was like Kansas or Nebraska or something. Then they made the assertion that that state is actually flat as a pancake.
Flatter than a pancake.
Oh yeah, flatter than a pancake. You know, I don't know how they did that and what form of measurement they used, but I thought that was interesting too.
They
and then
compare they compare the ratio of the height of like the height differences versus the length difference.
Okay.
Right. So if like you have an average height of say 1 inch, but the average distance between those 1 inch differences is like a mile, right? But if you had a whole bunch of those, it's really the difference between the roughness of a surface. You're just taking it's just it's the really thing how smooth it is more than how flat it is.
And with those measurements, you basically obliterate the sphere because there's no what is it supposed to be like 8 inches per square mile or of curvature or whatever it is again, a mile.
8 inches per mile squared.
I mean, yeah, regardless of how big the surface is, you should be able to calculate that and physically measure it, but nobody has. You know, it's
well, yeah. Well, we tell Globers that all the time that it's like they'll come in here. Oh, the Earth's too big to measure. Like it should be easy, super. According to their numbers, it's easy.
Right? How can anything be too big to measure? If that's the case, how did they measure and give us those measurements of the sphere? Even I mean, how did they do that?
BC
Where's the? Yeah, I mean, come on, it's silly.
If you can do it then, we should be able to do it now, yeah? With sticks and shadows.
When I get frustrated too with people that say, oh, well, the Coriolis effect and how come snipers, they need to account for curvature. They don't. That's not true. That's a total lie. Nobody that I know that target shoots and uses long-range rifles, nobody's creating equations for curvature when they're shooting at targets miles away. Nobody I know does that.
They would need to know their exact latitude and the direction they are pointing. Right?
Yeah, you do like elevation things and like wind
so complex. It's not like it's windage and elevation. It would be so complex, man. Like, fuck, you'd be there for hours and the target already moved.
And you would need your elevation too.
Yeah.
Yeah. You're done, man.
It's funny though because there are actually Glovers out there with rifles. I mean, I don't know how many of them are in the military. Probably not many, if any at all. But there are Glovers out there with sniper rifles that actually think they're accounting for the Coriolis effect. They think that.
Yeah, that's the magic, right? That's a magic trick that they're fooling themselves.
Look, it's one of these things where like, okay, say I'm shooting at a target, right? And like the accuracy of my bullet is going to be like a 6-inch spread. And the Coriolis effect predicts a deflection of like 1 millimeter.
I can't tell the difference between the so-called Coriolis deflection and the natural spread of the shots. Right? I can't distinguish. Did Coriolis affect this or not? Because just the natural variation of the flight of the bullet is larger than the deviation from the Coriolis effect. So it's like, what are you accounting for? Like, you have to be accurate within a millimeter when like your shot spread is 6 inches. Like, stop it. You're just being stupid at this point.
Well, they're talking to idiots that think bullets fly in like laser beam. Bullets are laser beams, you know, and that never spread, of course. You know, that's what they think.
Yeah. So like the what was it? The USS Iowa, the frickin' battleship, dude, with the 16-inch guns. You're like, this thing has to account for curvature and the Coriolis effect. Well, if you look up the firing chart at 30,000 meters, the Coriolis effect deflects it something like, I think it was 90 feet, right? Okay, yeah. But the spread, the randomness of where that thing lands, it was tested, and the mean spread is 250 yards, right? So you have, if you don't know the accuracy within 250 yards, what the hell does 90 feet matter?
Right. Yeah.
90 feet is a basketball court, and 250 yards is 2.5 football fields. So I don't know where it's going within 2.5 football fields, but I need to know with the accuracy of 90 feet. That makes no sense.
Right.
And just because
you're a science denier,
because it is in the firing table. It's in the firing table. Like they have the firing table. Like, yeah, this is what you're supposed to do. But if they don't do it, it doesn't matter. Like, it has no practical effect. They're not missing if they don't account for Coriolis.
That's why you're not a great shot, bro.
Anybody that knows about, and if you listen to people like, so I know some people that were like in Vietnam, right? So I know a person, he operated the radio, or he was a radio person in Vietnam. So he would get calls in, right? So he'd be like, we need artillery at XYZ spot. So he would call the artillery and say, hey, they need artillery. Now they know exactly where the people are, and they have all their firing tables. They would have to walk the artillery in because they don't actually know where it's going to land. They know within a certain range of where it might land, but they don't know exactly where it's going to land. So they would start short, right? And they would walk the artillery rounds in. Be like, okay, you're like, they would call, hey, you're still like 1,000 yards away. Go forward, another 100 yards or whatever. You know what I mean? And they'd make their call, and then they'd call, and then they'd call. They would coordinate where the artillery rounds are landing. They didn't just sit there and look at a calculator and go, this is where the bullet's going. It doesn't work like that. This is why I swear to God, Glober's never actually built or do anything in their entire life. Like, seriously. Or at least the ones that come around here. They've never done anything.
Internet trolls, man. That's what most of them are. Not all of them, but
I built the PC.
Well, I did that when I was like a kid, man.
Yeah, exactly. You plugged the parts together. You didn't build shit.
Fuck. 8 parts. 8 parts. You plug them in, the slots.
You can't even plug it into the wrong spot.
A lot of them can't for some fucking reason.
I want to see you try to plug an IDE cable in wrong. Go for it. I want to see you do that. You're going to be pushing for a long time.
They're the kids that bought like the snap together car, the little model cars.
Oh, the snap-on
you could buy the ones where you had to buy the glue and you had to buy the paint. They were buying the ones where you just snapped all the pieces together instead of actually having to glue every little piece meticulously to put it together.
Rich kids had them.
They wanted
Us poor kids, we had to glue it together.
I'm curious about like
way more expensive. Anyway, as a side note. No, go ahead. Sorry.
I was thinking about something else the other day. I was talking to somebody and they asked me a question about mountains in the peaks of mountains all around the world, and if the sun is so local, how do we have all that snow on those peaks of the mountains? Because they're closer to the they should be closer to the sun. So why does doesn't it, when the sun goes overhead, warm that and melt that? Which, I couldn't give an answer because I'd never even thought of that before.
In either model, it's the same, bro. Even on the globe model, mountains are still closer. So it's irrelevant, actually. It's very stupid of them to ask that. Because that inverse relationship exists in both models. So it's kind of quite a...
You're right.
I mean, to me, it's irrelevant because that's what it does anyways. So according to their theory, well, how? We're getting closer, aren't we?
Mm-hmm.
So, but of course, they'll say the height of the mountain relative to the distance of the sun is nothing, right? Just like India saying the accuracy, if you're 90 feet within your 250 foot, like range is nothing. So it's the same thing, really. And I don't know why it's like that. So if someone knows why, that'd be awesome.
It is interesting getting back to the gun thing because I had an uncle in law who he worked for the FBI, and this guy was a crack shot. I mean, we'd go hunting with him, and we could be driving in a car, and he'd be like, "Hey guys, watch this." He'd roll the window down on the car and like shoot something from just a ridiculous distance out of a moving car with like his revolver, and he'd be like, "What the fuck? How did you do that?" You know what I mean? He could just shoot the flies or the wings off a net. It was ridiculous. And it doesn't matter what gun you handed him, he could hit the smallest target, whether it was moving still or whether he was moving. It was unbelievable. And he never had to sit down and do no calculations. Said, "Well, hold on, let me figure this out." No, he just pull that gun out, aim and shoot, and he would hit it every time.
But that's because he was accounting for Coriolis every time, and you didn't know about that.
In his head, he was calculating in his head.
Well, you don't know. He was very smart, man. He was government trained. He can do this stuff in his head. You're not. Gotta troll you a little bit, man. Why not?
No, yeah, we gotta laugh and keep a sense of humor about it. Otherwise, we go insane, right?
Oh yeah, man. Gotta have a good time.
Hey, if you guys want to look at something kind of funny, yesterday I was downtown handing out those QR code cards, with the Discord server QR code on them, and I ran into a woman who was handing out these pamphlets for Scientology. I just posted a picture of the front of it. I just thought it was kind of funny, interesting. I was asking her, like, doesn't that religion have something to do with planets and like aliens coming here to seed us from outer space and stuff? And she was like, I don't know what you're talking about. She I guess didn't know anything about that, but I was like, oh, maybe there's more than one type or something. Or maybe I heard wrong. I don't know. I just thought that was funny. So maybe she didn't know her own religion that well. I don't know.
Yeah, she's not privy to the secret doctrine yet.
Yeah, John Travolta made a whole movie about that. It's a horrible movie, but great for a watch if you hate horrible, painful movies. It's really hilarious. But he made an entire movie in that whole
Battlefield
I can't
Earth.
remember what it's called. Yeah, Battlefield Earth. That's all that's all that's what they believe. That's their religion. That's like the backstory. That's their Passion of the Christ, if you will.
I knew he was in that movie, but did he like produce it and direct it?
Oh yeah, he I think he paid for it, and it took him years, and he spent a ton of money on producing that film, and it was a huge flop. But yeah, you can look all that up. It's he had a big hand in that. He's like a god in that religion. Him and Tom Cruise.
There was some funny stuff also on the backside. I'll post 2 pictures of it. It's kind of hard to get in one picture, but it like had all this weird stuff having to do with like personality tests and feelings or something. Some stuff I didn't understand. But I'll show you guys the back of this thing.
Yeah, they talk about that in another film they made about L. Ron Hubbard. It's got Joaquin Phoenix in it, and I want to say Philip Seymour Hoffman plays L. Ron Hubbard, but I'm not sure. But they show that he goes through those tests, and it's pretty interesting and bizarre, but it's also really stupid. It's a boring, painful movie, but if you're into that, you might want to check that out. I don't know how honest the film is about how the tests go, but I don't know, it's interesting nevertheless.
Yeah, I'll also post a little YouTube clip. I actually recorded me talking to this woman because I thought it was, kind of funny, like someone being like, "Hey, Scientology, the planet was seeded by aliens or something like." Well, even though she wasn't saying that, but part of that religion, And then like I'm handing out these cards that are saying the Earth is flat and stationary, and the necessary